When we're doing astrophotography, we need to have some sort of control center for our equipment. So some sort of software that can control my camera, that can control my focuser, my filter wheel, if any, that can control my guide camera, that can control my mount, that could potentially control things like a flat panel, this kind of stuff, or even a rotator. And depending on the choice that you make for this tool, what you're able to do with it, like the amount of features that are available, the limitations, etc., are different. A lot of people, when they start in the hobby, they go for the excellent and very easy to use control center that is called the ASIAir. It's a one-stop shop where you have a single box with power outputs, USB outputs, and the software to control your equipment, but it does restrict you to ZW cameras, ZW guide cameras, ZW filter wheel, ZW rotator, and ZW focuser. It has a large number of mounts that are supported, as well as DSLRs to some extent. But it does mean that you're restricting the universe of equipment that you're able to use with that control center. At the same time, I personally think the ASIAir lacks a lot of very convenient features, especially when you're using a monochrome camera. Things like filter offsets, the ability to take images with one filter, then the next, then the next, then the next, all in a loop, so that you always have like all the colors that you want to capture, even after a single night of imaging. It can have issues with longer focal length, etc., etc. So there are limitations to the ASIAir. And if you are limited with the ASIAir, I see a lot of people looking at other potential solutions, such as using a mini PC with Windows installed on it, and then you can put the free and open source software called Nina, and Nina can control everything. It has a huge amount of features. It is, once you've set it up correctly, very easy to use and can be fully automated, so that you could basically like click on a button and then everything is done automatically, including copying the images taken over network to your processing PC, for instance, using a plugin for Nina. And of course, it supports pretty much any piece of equipment that's out there that has either a native or an ASCII driver for Windows, which is pretty much every single piece of equipment for the hobby. Plus, via some plugins these days, it can offer some surprisingly capable smartphone interfaces, and it has a lot of good stuff going for it. The problem with Nina is that there is a learning curve, and it's not easy to just pick up, especially if you're a beginner in the hobby, or you're very used to something like the ASIAir, because then the paradigm changes, and there's a lot of things that you need to get used to until you have it configured exactly how you need. And this video, I hope, is going to be a masterclass for Nina, so that you have everything from the installation to plugins, to how to do Platesolving, to focusing, to advanced sequencing, everything in a single video. And so that's going to be likely a long video. I'm probably biting off more than I can chew, but if I publish the video, it probably means that I'm done. Maybe I'll just end up publishing it in pieces, but let's get to it. And let's start with the initial state. I'm making the assumption that you already have a mini PC, or any PC that you're going to use to control your rig, and that you have Windows installed on it. And ideally, you also want to have something like Remote Desktop, Chrome Remote Desktop, TeamViewer, that kind of software set up on the PC so you can access it remotely. And if you're not sure about how to set up the PC, I have complete videos on the topic, so I'll put a link up above and down in the description. The instructions for hotspot are a bit old, but besides that, it's still very much applicable in terms of the flow. But now you have your mini PC, it has Windows on it, and it is time to install Nina, so let's do that together. Okay, I'm on a remote PC, which is actually my Gaius S2 computer. It's both a mini PC as well as a power box, dew heater controller, and it has tons of USB outputs. So I'll put, by the way, a link to my review of that mini PC up above and down in the description. Excellent thing for Nina. It also comes pre-installed with Nina, so you normally do not have to take the steps that I'm going to take, but just so you know. So I'm connected to that remotely, and I am on the page of Nina. I'll have all of the links in the description, of course, where I have my the requirements, which gives you actually a good list of what you need to install to have Nina ready for you. You need the ASCOM platform, and the ASCOM platform is basically just a platform that can support various drivers for your equipment. It says it's recommended. I would say overall it's a must. PhD2 guiding, which is the software that will let you auto-guide your scope so that when you're pointed at a target, you can use a secondary camera and scope or off-axis guider to really keep track of what you're pointing at, so you can take very long exposures without issues. Or you could use meta guiding instead. Most people go for PhD2, myself included. Then you can choose one plate solving application. So plate solving is basically just saying that when your telescope is pointed somewhere, the Nina can instruct the camera to take a picture. The camera will take a picture, and the plate solving application will analyze the stars in that picture to determine exactly where the scope is pointed. So that's what plate solving is. Things like the ASIAir do that automatically. For us, we need to install a free app. And I personally recommend either ASTAP or, if you have a long focal length, Platesolve 3. But we'll get to that during this video. And we can also install Planetarium application. I personally don't really do that, and this is very optional, so I will not cover that in this video. And also, we have the Sky Atlas image data. This is some additional data for Nina when you are choosing a target to image. Do you want to have like a preview of what that target looks like, yes or no? If yes, you want to download the Sky Atlas image data. I highly recommend doing so. But let's get to it in order. We first start with the ASCOM platform, which is available at ascomstandards.org. At least, again, we'll have the links down in the description, and we can just download and install the latest version. So it's already downloaded. I actually have an older version installed, so it will be a good opportunity to install for me the latest version. So I'm just going to double click on the installer for the ASCOM platform. And I do recommend running it before you install Nina. Okay, we have the installer window here. We do want to basically keep the default options. We don't need any of the out-of-date stuff. So I can just click on install and let it do its thing. Okay, and after quite a bit of time, the platform is installed. So I'm going to click on finish. Now, it would be tempting, now that we have the platform that supports drivers, to go ahead and install drivers, but actually no, it's better to install Nina first, and this is because a lot of drivers these days are bundles that contain both ASCOM drivers and native drivers, and it will try to find Nina, and if it does find Nina, it puts driver in there. If Nina is not installed, it doesn't find Nina, it doesn't put a driver in there, you do not collect $20,000. Etc., etc. So we need to download and install Nina. So I'll go to the Nina download page, and I'll just install the stable version for now, although already the 3.2 nightly versions are working perfectly fine for me. But out of precaution, let's go with the stable version. So I can just download it from here, and it gets downloaded here as the Nina setup bundle as a zip file. And I can go in there and say like, yeah, I want to extract everything into its folder, have it opened once it's done, and then I can run the installer for Nina in there. Okay, so in there, I can just agree to everything, click on install, and everything will be done automatically. It's freeware, it's open source, it doesn't install anything weird on your computer, just Nina, and it works great. Okay, here we go. We can launch it for the first time, which can be appropriate so that you know that it has like created all of the folders that it needs to create, etc., etc. So let's just launch it, and it will launch as it shows right now, something like this, without any real details in there. So let's, it's launched, everything's ready. I'm just going to close off Nina, and then we can go to the drivers. So drivers will obviously depend on the equipment that you have. For a lot of people, you would have like ZW equipment. So what you'd want to do is just go to zwastro.com/software and download the latest camera driver and download the latest ASCOM driver, which can be good to control your electronic focuser, your mount, your filter wheel, etc. So you want to download both the camera driver and the ASCOM driver. And you can see I have both of them, so I could just run the ASCOM setup for the ZW equipment that I have. And I can choose, what to install, whether it makes sense to install all of that, which, why not? I'm just going to have everything on the computer. It will remove first the old ASCOM installation that I have because I'm just showing you how it's all working. And we can proceed with the installation. Okay, let's click on Finish. We're done with the ASCOM drivers. We do want the camera drivers as well. So I'm going to double click on the cameras installer. Again, it will tell me like, okay, you have, already installed because it's on this system. I'm just going to install it again just to show you. And we're going to validate install, and it does everything on its own. Finish. We're done with the ZW stuff. But you could have other cameras. You could have cameras from TopeTech Astro. So in this case, you would go and search for the TopeTech Astro software, and you have the ASCOM driver here. And actually, even though it says ASCOM, in terms of TopeTech, it actually installs the native camera drivers as well. And so you can go ahead, download it, install, and it will install all of the drivers. Just again, I'm removing the previous version, installing the new version because it was already installed on this particular computer, but for you it would likely be new. And finish. There we have it with TopeTech stuff. There's one thing with TopeTech is they also provide like DLL files, which are like basically raw driver files without an installer. And if you ever have a TopeTech camera that doesn't work after installing this driver there, another thing that you could do is download this DLL, which they tend to update fairly often. And with that DLL, you can go to C, Program Files, Nina, that's the default installation folder. Then you go to External, x64, because I assume you have a 64-bit computer, as most people do these days. And then you can put the DLL in TopeTech and rename it to topecap.dll. So I could, download this. You see it downloaded topecam x64.dll. So what you would do, you would take the DLL that you've just downloaded, rename it to remove the x64 here, and then you could drag and drop it to the folder we just looked at. I'm not going to do that because it's already, I know it's working, but that is something that you can do if you ever have trouble with TopeTech cameras. There's other equipment that you could be looking at, for instance, like QHY-CCD cameras, where you can go for the download. Again, they have like a full package, either a beta version or a stable version. And if you were to install the, let's say, the beta version, I think this is what I have here. Again, it would simply be opening that up. Although for QHY, we do have something a bit specific about them, which is that it will ask you to select Nina during the installation, and also it tells you to close all camera connection applications and disconnect any QHY-CD device cable before doing the installation. So actually absolutely do that. Do not forget to do that. It has caused issues for me in the past. So we can go next, still validate, and this is the important stuff. You have the drivers that you want to install, and then there's this third-party software support. And this is where you want to say like, oh yeah, actually I want my ASCOM drivers. I want ASCOM driver for the QHY filter wheel. And if I have an older filter wheel, maybe I want this one as well. If I have SharpCap installed, I want to select SharpCap. And then, very important for us, if I have Nina installed, I want to select Nina there. And if you don't select Nina, especially if you have something like the Minicam 8, which is very recent, which means that the stable version of Nina typically does not come with the driver that supports the QHY Minicam 8, then if you don't select this here, the QHY Minicam 8 will not work within Nina. So for us, it would really be like selecting all of those before installing. Now I already have the QHY stuff installed, so I'm not going to proceed, but that's something to remember if you're doing QHY stuff. And then you want to install anything you need for your equipment. For instance, I have a flat panel from RB Focus, and I can install it via the RBF Excalibur setup.zip. I also have a WD-20 mounts from Warp Astron. So I'd want to go to Warp Astron and go ahead and download the driver for my mount, and that will be an ASCOM driver. I could go to support, software and driver, and you can see I need to actually download two things for this particular mount. The COM driver, which basically lets the computer identify that the mount is connected, and then the ASCOM driver that lets ASCOM and therefore Nina communicate with the mount. So you would go both steps before it's available. I've already done this on this PC, so I'm not going to go through the details, and it's also very equipment oriented. But if you had, like, let's say a Skywatcher mount, then you would go and get the SynScan drivers, or better, something like Green Swamp server, which is what I use to control my Skywatcher mounts typically. So you would go in there, download it, and then you'll be able to actually control your mount using the Green Swamp server software. But this is like the drawback of supporting all of the hardware that is available on the planet, most of it actually. It's that you need to install the drivers separately, whereas something like the ASIAir comes with all of the drivers pre-installed. Even stuff like the Toptech Stella Vita or the StellarMate Pro have the drivers pre-installed, so it's a bit of a Windows thing. But let's say we have everything installed in terms of drivers. We're very happy about that. So the next step would be what? The guiding. So we would go to PhD2 guiding. Here we go. And I would just go download the latest version here for Windows. And we can just double click to install it. Okay, so let's run the installer for PhD2. I'm going to say Windows, yes, you can run it. It's safe to run. And we can install just as usual. Okay, now that I have PhD2 installed, actually, rather than launching it directly, I would recommend, since we have installed all of the drivers, to restart the PC once. So I actually already restarted the PC, and we can launch PhD2 guiding. I'm also going to right click on it and to say like pin to taskbar, so I have it always available to start. And on first launch of PhD2, it should come up with the new profile wizard here. So we're going to go into the profile wizard, and it will first ask me to choose a guide camera. And my guide camera is actually a ZW camera, so I'm going to select that, and it asks me whether it's already connected. I'm going to say yes, and it has detected it. It is the ZW ASI 220mm guide camera. And what's very important here is to set up the guide scope focal length. So if you have a guide scope, put in your guide scope focal length in there. If you're using an off-axis guider, it should be the same focal length as your main telescope. And for me, I'm using the Carbon Star CS150 from Apertura. And so with the coma corrector that does a little bit of reducing, it's around 570 millimeters. And that's important so that PhD2 knows what one pixel corresponds to in terms of angle of the sky covered by that particular pixel, so we know how accurate the guiding is. So I'm going to click next, and now it's going to ask me for my mount. So for that, it's going to be an ASCOM mount, and specifically, it's going to be an on-step telescope because my WD-20 would be on step. For you, you need to choose the correct driver for your mount. And if the mount is already connected, you want to click yes, because it's also going to set up the mount guide speed, which is also somewhat important. And now it's connecting to my mount, and it is connected successfully. And it did read from my mount that the guide speed is 0.5 sidereal, and for some of you it will be 1, but most of the time it's 0.5. And you can change that in the mount settings, sometimes in the driver as well. So if you had like a Skywatcher mount, you'd be using Green Swamp server. If you were using a ZW mount, you would select ASI mount in there. But the principle is the same. I'm going to say next, and then there's like adaptive optics, none. There's a rotator. I don't use one, but if you did, like the ZW CAA, you would select it here. Click next. And you could build a dark frame library if you wish to. I'm not going to do that right now because it's raining outside, and yeah, I don't want to risk opening up the equipment or whatever. But it is good to actually have a dark library, and I would recommend doing so. But otherwise, don't bother with it. I also want to suggest to select Auto Restore Calibration because that's a nice option to have, and I'm going to call this equipment like WD20 CS150. Right, this is what we're using. Click on Finish, and that's it. Now sometimes the flat wizard, or the wizard, when you launch PHD2, can have some bugs. If it closes on you, you can always access it again by going to this kind of like USB icon here, and then here you can select New using Wizard. And now that I'm in there, by the way, I'm just going to connect everything. So I'm going to connect the guide camera, and I'm going to connect the mount as well. And there it is. It is connected, so I could, cycle through my frames. Right now, the camera is mostly covered, so we see only a little bit, tiny bit of light. And I can also go to View and say that I want to display the chart, and that will show me the guiding chart for declination and right ascension. And I can also display things like the star profile and all sorts of information that can be available. All of that typically is not super needed, but it's nice to have in there like that. Nice little PHD2 interface, and we can only use it to calibrate it once we get a nice clear sky. So I'll go back to that in a bit once I'm able to really go under a starry sky. So PHD2 is working. I'm going to stop the imaging. So if you want to start, the frames taking it this double arrow. If you want to stop it, it's there. And then you have additional settings under that brain icon. Typically, you don't need to really change them because we've already set them up correctly in the wizard at the start. If you have a strain wave gear or harmonic type of mount like the ZWAM5 or my own, the WD20, you'll want to have an exposure length of 1 second or even 0.5 second. If you have a traditional mount, with like a standard worm gear kind of mechanism like the AQ6R from Skywatcher, something like that, you can select up to 3 seconds, and that's what I would actually recommend if you have such a mount. But for us, it's strain wave gear here, at least from my rig, so I'm going to select 1 second and put that in icon. And now I will go back to the Nina requirements list to see what else we need to download. Okay, so we have PHD2 guiding installed and ready to go really, but now we need to also install a Platesolving application. So as I was mentioning earlier, I recommend either ASTAP or Platesolve 3. And if you have normal telescope, normal focal length type of stuff, ASTAP works great. But if you have a long focal length, let's say 2000 millimeters, Schmidt-Cassegrain is an Edge HD 11, for instance, which is like what, 2800, something like that, I don't remember. Very long focal length, especially if you pair it with small pixel cameras like the 585 sensor or the 183 sensor. You absolutely want to use Platesolve 3 because ASTAP will not work well with that. So you have the choice between the two, and you can actually install both if you ever need them. So ASTAP, you need to install two things. You need to download and install the main program of ASTAP, and you need to install and download the star catalog, star database. And if you want to be safe, just go for D80. It's going to be 1.3 gigs of installation space of download to do. If you have a fairly wide field rig, as I do, then D50 is enough. But if you want to be safe, just get D80. And then you want to just install in order, starting with ASTAP. So I've already downloaded ASTAP. It should be there. So you want to first run the ASTAP setup. And I'm going to run anyway. Here we go. And it's already installed, so I'm not going to go through the whole process, but that's what you would do. And then the next step would be to install the star catalog of the star database. You can see I have here the D50 star database, but likely you will have downloaded the D80. It's exactly the same thing though, so you can just run that as is, and it will detect the folder where ASTAP is installed. That's why it's important to install the main application first, and you would just click next, 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 etc. For me, I don't need to do that because it's already installed, so I'm going to exit the setup. Now, if you went with Platesolve 3, rather than using this link here, which brings you to a huge download page that has a lot of stuff that is very unintuitive to use, I would recommend instead going under the documentation, advanced topics, Platesolving, and then scrolling down, and I'll put the link again down in the description, but you should have Platesolve 3 here. And in here, you just need to click on this and download this particular file. And then you want to just install it. But that's limited to if you have like a long focal length rig. Typically, you would not need it. Although, if you are switching over from the ASIAir to Nina in order to support a long focal length, because the ASIAir can have trouble with that, then you definitely want to install this. So that's Platesolve 3, and that's some of the software that we need. Going back to the prerequisites, I already said like a planetarium application, I don't use one, so we're not going to install that. And then there's the Sky Atlas image data. So I can click on that, it actually brings us to the main download link. And you just want to go to the very bottom, and you have the offline SkyMap cache here, 3.3 gigs that you can download, which I've already done. And it is this zip file here. So again, I would just go ahead and extract all as a folder. Oh yeah, I'm going to show the extracted files when complete. It's going to take a bit of time because it's a large archive. Okay, we have it unzipped, and if we open up the folder, we'll see that it's just a series of JPEG files, a lot of JPEG files. And what I like to do is to just put it somewhere I'm going to remember, and we'll be able to set up Nina to have a look at it. So I'm going to Control X to move it to Documents and validate that, and we now have it in Documents. And now we should be ready to launch Nina and set up Nina. So we've already installed ASCOM, we've installed all of the drivers, we've installed PhD2, we've installed the Platesolving software, we've installed the Sky Atlas preview basically, and we've installed Nina. Everything is ready, so let's launch Nina and go through the first setup to get really everything dialed in. So I'm going to select Nina in my start menu. I'm also going to pin it to the taskbar so I can use it anytime I like, and let's launch it for the first time, see what happens. I mean, actually second time, because we've already launched it once before installing all of the camera specific drivers. Here we go. So we are here and we have several tabs here, and we're going to basically go through each of them in turn. Okay, so we are in the equipment tab of Nina, and we have a list of equipment that we could just connect to. And after you've connected once, Nina will remember that. So it's a kind of like a one-time type of deal, although I like to kind of do it manually every time I launch Nina because it brings me closer to my equipment. It's a psychological thing. But we'll start with the camera, and in theory, if you open up this drop-down, you should see the cameras that you have connected to the system. This one is the camera for PhD2 for guiding, but my main camera is the QHY Minicam 8. If you do not see your camera in there, it might be that there are no native drivers for Nina, in which case you can choose the ASCOM version of that camera. Or it could be that the USB cable has issues. It's not plugged in well. It's not given 12 volt DC, for instance. This camera, the Minicam 8, will not show if I don't have 12 volt input into it. That kind of stuff. So you do need to double check what's happening there in that case. And after you fix the issue, you can click that refresh button for Nina to recheck which cameras are connected to the system. For me, it's the Minicam 8, and I can just connect to it. And you can see I have a default gain, default offset, USB limit, and then the cooling capability on the right-hand side here, as well as readout modes, which I like to have as full resolution. And in terms of gain, it's just like on something like the ASIAir, you need to choose the correct gain for your camera. If you're using something like 2600 MC or something like this basically, or 6200 MC or MM, or a 533 camera from ZW, I would recommend gain 100. If you're using the QHY Minicam 8, I think 80 is the gain at which the high conversion gain is triggered, so I'm going to choose that. And you might have things like full resolution, or if you're using Taupe Tech, you'll have like the choice of low conversion gain versus high conversion gain directly in these options. All of that, it's nothing to do with Nina really. It's all about your camera itself. So you want to check your camera specifications to see what would be the right numbers to use in there. The only thing that you do need to set up yourself is the offset. And the offset is basically, what you can do is, I have a video on the topic, so I'll put the link down in the description and up above also if I don't forget, where you can basically cool the camera first. So to cool the camera, you can have Nina do it automatically when you start a sequence, but you can also do it manually. I could say like, okay, cool to -5 degrees Celsius here, and then click the cooling icon there, and now it will start to cool the camera. After you've cooled the camera, place the dust cap on. Make sure there's no light leaks of any kind. Then just use the imaging tab, we'll get to it later, to take 1 second exposures and just change the offset until you find the lowest value of the offset that allows you to not have any pixels with a value of 0. That's how you set your offset. And it's an option that is not available in the ASIAir because ZW sets it automatically for you. It sets a value that is a bit higher than optimal, but that way it's sure it's going to work with every single sensor or variation of the cameras that they have. The offset, if you set it too high, it will compress a little bit the dynamic range that's available for your camera, but it's not a big deal. Okay, let's go to the next tab, which is the filter wheel. And for me, again, this is a filter wheel that has a native driver. So it's available directly in there. But for a lot of people and a lot of filter wheel, including ZW filter wheels, you would need to select ZW filter wheel in there and then click connect. I don't have that. For me, it's the QHY Minicam 8. I could try to connect via the ASCOM driver and, click on connect, see what happens. Yeah, it has issues there. I think it wants me to connect the camera via ASCOM in that case. So I'm just going to go for the native driver, click on connect. And you can see we have our filter wheel connected, and it has detected all 8 slots of my filter wheel, but they don't have any real nice name yet. Don't worry, we'll be able to change that soon. Then I can go to my focuser. My focuser is based on an ASCOM driver, and it is a Gemini focuser. So it uses my FP2 ASCOM driver there. So I can select that, and I can click that little gear icon as well to see the ASCOM driver parameters, including the port that is going to be used to connect to the focuser. If you ever try to connect a focuser or a filter wheel and you do this and it gives you an error message at the bottom right, chances are, for me it just worked, but chances are you need to change the port that is being used. So for instance, I can show you how it would look like. Let's say I've selected the wrong port. I can try to simulate that. Let's select COM1, click on connect, and then I'm going to try to connect to it again. I think it will give me an error. There it is, like unable to connect. In which case you want to go inside the ASCOM driver and select each port you have on your computer one after the other until it works. Again, it's a one-time thing, not a big deal, but it is something to do at first. And you can see that within this, you can see the current position of the focuser, and you can change the position either by setting a value in there like 50-50 and then clicking move, or you could use the arrows underneath here to do a small movement or a large movement. The values of that are in the settings, so let's not do it yet. Then you could do the same for a rotator. I don't have one on my rig, so I'm not going to connect a rotator, but I can connect my mount. And for me, it's going to be the on-step telescope mount. For my particular mount, I can click on the gear icon, and you can see that for me, it's going to be on COM6. Apparently, I have a lot of parameters in there. But again, those parameters have nothing to do with Nina, everything to do with the mount. I just have my limits in there. that I have set up already in the past properly, and I'm just going to connect to the mount. Now this will give you a dialog where usually it will tell you like, hey, your mount has some coordinates set up in it. Do you want to sync with Nina? And you can choose whether the mount coordinates are correct or the Nina coordinates are correct. For me, the Nina coordinates are 0, so they're incorrect, and the mount is actually correct. So I'm just going to say from mount to Nina, and that will actually upload or update the position that I have in Nina to whatever the mount has in its parameters. Okay, so the mount is connected. I can go to the next one, which is the guider. And the guider, I can just select PhD2 because we have PhD2 installed. And normally, after selecting PhD2, you can just click on the connect button and it should connect to it. If PhD2 is not installed, it's not launched, it will actually launch PhD2 automatically and start going through the frames of PhD2. So just for the heck of it, I've closed PhD2 and I'm going to connect to it from Nina while PhD2 is closed, and you can see that it launches PhD2, connects to the whole equipment, and then starts looping the images. So we're ready with PhD2 connected to Nina. And then for me, my particular computer, the Gaius S2, has a switch where I can control the power ports of the computer. And that's, for me, an RB Focus power controller switch. And again, I can check the gear icon to select the proper COM port and then connect to it. That lets me control the power ports directly from within Nina, and those can be controlled from within the sequence as well. And finally, I do have a flat panel that can be controlled via USB. That also is a flip-flap type of panel, so I can like open it remotely. It acts as a dust cap for a telescope, and it's going to be RBF Excalibur. And again, you need to select the right COM port in the settings, but I'm going to connect to it, and now the flat panel is connected, and I can open it, close it, change the light intensity, the brightness of the light, etc., etc. Now I can control everything, and we have basically all of our equipment connected. Of course, for you, you will have different equipment connected. This is probably the hardest step because everything has to work. Everything has to be plugged in correctly. You have to find the right COM ports. You have to have the power working. And this is probably the steps where you will have issues. But if you've installed the drivers carefully, especially like QHY, Select, Nina, that kind of stuff, it should work. And here it has worked without too many issues. Okay, so now this is for the equipment tab. I'll go to the next tab, which is the Sky Atlas. And the Sky Atlas, we don't really need to use it right now, but we could say like, okay, let's search for M32, and it tells you like when it's gonna rise, assuming your coordinates are correct. But remember, we synchronized the mount coordinates to Nina, so they are, and you can also, slew to the target, set for framing assistant, or add target to the sequence to take an image. And you can filter all sorts of stuff in there. I'm not going to spend too much time on there, but you could say that, okay, I want to have like an object that is above 30 degrees altitude from whatever, like 10 p.m. to, let's say, 2 a.m. And it should, it will be visible for more than 1 hour, and I can select an object type, etc., and then click search. I'm going to remove M32 there, click search, and it will suggest a lot of potential targets that follow these criteria. And here it is. And notice that we don't have any images yet. This is because in the settings, I have not yet set up the image catalog that we downloaded and unzipped earlier. Then we have a framing wizard. Framing wizard is very similar. But right now it's not yet usable because we need to first set some things up in the options. So we can go back to it later. There's a flat wizard. I'll go back to it later, but it lets you basically take your flat frames automatically super easily, and in my opinion, much more easily than the ASIAir, especially if you're using monochrome and multiple filters. Honestly, it's kind of magic. We have the sequencer. I'll go back to it later because this is where you can plan your sequences. And there's a simple sequencer and an advanced sequencer. The advanced sequencer is absolutely amazing, and we'll get back to it later. Then we have an important tab, which is the imaging tab. And this is where you can really, like, we've already connected all of the equipment, right? So I could ask Nina to take a 1-second exposure with my camera using this imaging thing here, and you can see 1-second exposure. And I clicked here to take one exposure, and you can see the minimum value is 1472, although I don't have the dust cap properly on, so it's kind of invalid. But I could be changing my offset. Actually, I think for this camera, an offset of 8, if I remember, was a decent value. So I could go back to imaging, take a 1-second exposure, and here we go. Now, like, the minimum value is 48, pretty decent in terms of setting my offset. But in here, you have a lot of options that are available. You'll have like sequence information, star size, and autofocus information. You'll have an image history, and you can have multiple tabs within a single window. So I could say, like, I could click on this autofocus thing. It will add an autofocus control tab, and I can actually drag and drop here and say that I want this to be part of this window by selecting the center or by hovering. I'm still clicking here, and as I release here, bam, I have autofocus and image as 2 separate tabs here. And I can, move them around as well. So image is the first one, then autofocus, and I have other options in there like Platesolving. Bam, I can add Platesolving and again, move it to the center area to have it available as a tab, and I can do Platesolving of my targets from here. So that's like the kind of like the control center for Nina in general. And now we go into the options, and that's really where we need to do the initial setup. So first things first, you have the profile here. And the profile is basically an equipment profile. You can have multiple of those. And I could say this is like CS150, so my Carbon Star 150 equipment. And it has remembered all of the equipment that I had. And I could create a new one or duplicate the current one if I was moving my computer between different rigs. But right now we're just going to be with one single profile. We can also do some other stuff in there that can be very useful, which is, for instance, have a custom horizon, where you can create a horizon file and import it into Nina so that when you go back to the Sky Atlas and you look at your targets, you have like your horizon visible for each of the targets. And we can do that maybe a bit later. And actually we'll do the horizon for Nina right now because we can and we should. And I'm standing right next to the rig that we are setting up via Nina. So I have my guide camera, I have my main camera, I have the flat panel, I have the mini PC, and I have the mount and the focuser as well. So this is what we've all been connecting. It's always good to go back to the actual equipment that we are working with. But now basically the idea is that I want to have a file that lists a list of compass points, so directions, saying like, okay, true north would be 0 degrees, roughly there. South would be 180 degrees. East would be 90 degrees, west is 270 degrees, right? So what we want to do is have a list of those azimuth angles together with the elevation of my horizon. And there's an app on iPhone devices called Theodolite, I believe, that costs like, what, $14? That can do that for you, but I don't have an Apple iPhone, or any Apple device for that matter, so I cannot use that. But there is a free app that lets us do that, and I'll put the link to that free app down in the description. So this free web app is called Gyrocam, and basically what you'll need to do is you'll set your magnetic declination so that the app can understand the azimuth in relationship with the true north compared to the magnetic north, because they're two slightly different things, and we want the true north. And there's a convenient list of cities there, and Tokyo is -8, so I've put in -8 in there. And then I can tap on the play button. The play button will actually open the camera, and you can see that I have a view of my horizon, so I can pick this point and say we're going to add this point. And at the very top here we have the azimuth and the elevation. So we'll be able to have like a grid of azimuth with elevation when it comes to the horizon. The problem that I have with that is that the azimuth, look at the azimuth, and I'm staying at this in the exact same direction, and yet the azimuth is changing dramatically as I change the elevation of my phone. So it's not very reliable, which means that I have a backup, which is a digital compass on my watch for now. And I'm going to use this digital compass in addition to the elevation that's taken by that. So I would say first point here would be this, and I click the plus button at the bottom here. And for the first point, it tells me azimuth is 120, but I'm going to check with my watch, and my watch says for the same direction, it is actually correct. So 116 from my watch. So, and I've configured my watch to be true north as well. So I'm just going to write down on a piece of paper 116 for point number 1, 116. That way I remember, and I have a double check on the azimuth. Then I can go to the next point of the horizon. Immediately, we go to an angle of 3, so very low angle. I'm going to click the plus button. This time, the azimuth looks very wrong. So again, I'm going to check my watch. My watch tells me the azimuth for that is more like 120. So I'm going to put 120 down on my notepad so I know exactly the angles. Then the horizon is more or less flat for quite a while. It rises up maybe a little bit here, but I'm just going to assume it's flat, and that's easy for me to do. And it's still flat, 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 so we're not changing really the elevation, except here I have a TV antenna that I'm actually not using. But basically, I'm going to take another point here, and it's going to record the elevation. I can check, by the way, by tapping here my list of points. And I'm going to double check with my watch compass that tells me the azimuth is actually agrees with the azimuth there. So we're good. And then we have this area here that tells me I'm going to take another point. Bam. And that's basically all of the points that I need. So that other point that I took, I'm going to check the azimuth with the watch. And again, the azimuth agrees with what the app recorded. So we're mostly good, and I'll have only a few changes for the first 2 points that I recorded with the app. The app told me the first point was as azimuth 121. The real value was 116. And then the second point was at azimuth 88. The real value was 120. So that's why I'm using this notepad. Whenever the app and my watch have a disagreement, I'll be using the watch. And so now from the app, I'm gonna again check the list of points I have. So I only have 4 points because I have a relatively simple horizon to deal with, because most of it is actually relatively flat. And anyway, I'm never going to image less than 30 degrees above the horizon because, well, it's Tokyo and the light pollution is horrendous, especially close to the horizon. I end up with those 4 points. And I just know I need to amend the azimuth for the first 2 points. But then after that, we're just going to be good. And I can copy this using the copy button there as value, or I can save it as a file. And that's what I'm going to do. And I'm going to send myself this file over email so that we can edit it. And once it's edited, we're going to give Nina that file so Nina can work with it. So let's go back to the computer so I can show you how it looks like to import the horizon file into Nina and the impact that it has when we search for a target, and also the impact that it has in terms of Nina understanding the horizon for your particular site. Okay, and here is basically the file that we got. We had like something like ASIAir, something like that at the top, right? So you just remove the first line of the file that is created. And then what I did is here we had another value, something like 88. I replaced it with the notes that I had taken based on the compass on my watch, which was more accurate, especially when I was angling my smartphone. And the way that this works is that we're saying like, okay, at 116 degrees azimuth, the elevation of my camera was 26 degrees up, right? So that's where the horizon is. And then at 120 degrees, so just a short, like very little later, it's at 2 degrees. So that takes care of like this kind of roof that I have right next to my rooftop balcony. Pum, pum, okay? And then I also measured at 357, so almost due north actually, and I kind of take it large because I have this antenna that's like sticking out. I could try to do it a bit better, but anyway, at 357 we have an elevation of 47 degrees, and then at 53 we have an elevation of 42 degrees. Now, the thing here is that what Nina will do is it will trace straight lines between each of those points. And so between an azimuth of 120, which is basically southeast, and an azimuth of 357, which is basically due north, I will have to switch between 2 degrees elevation and 47 degrees elevation. So, which means that Nina would just draw a diagonal line between the two, which is not correct. I want like a straight line like this and then a straight line like that, basically. So I need to add another point saying like, oh yeah, right before my antenna there, at let's say 354 degrees, we're still at 2 degrees elevation roughly. So that means that now Nina will know that between 120 and 354, we have a straight line that is all the time at 2 degrees. And then after that, very quickly, we get to 47 degrees. So I'm just manually adding this little data point there that I kind of effectively forgot to take. So you always need to remember is like we are drawing just straight lines between points. And that's what Nina will do. And once you have that in a text file, so I'm using Notepad, right? So just search for Notepad and open up Notepad, copy paste in there, basically. And I saved it under Documents, Horizon.txt. That works perfectly fine. So I'm saving that again just to be safe. And then in Nina, what we can do is to go back to the general options there. So options, general. And the custom horizon, I've already set it up with this particular file, but you just browse for files, select your horizon file, make sure you never delete it. You may also want to keep a copy somewhere like on Google Drive or something like that in case you do ever delete it or you install Nina on a new computer, that kind of stuff, so you can just retrieve it back and use it again. And now, if I go to my Sky Atlas and I search for like M31, for instance, you see that I have this green area there that effectively represents my horizon. And I could search for other targets, let's say M32. And again, we have this kind of thing that happens there. And so it's adapted based on the azimuth of the target throughout the night. And now we know when the target will get above my my little like rooftop balconies. Rooftop, I don't know how to explain that, but now we have represented the horizon. And so whenever I'm using something like a sequence, and in sequence, it's going to be spoiler alert for the rest, you have tools like, for instance, wait until above horizon. And that uses your custom horizon if you have one set up. And I could even say like, wait until the target is 5 degrees above my custom horizon just to be safe. I have also like loop while the next target is below horizon. It's going to use again the custom horizon so we can look ahead of time. And I can combine that with a wait for altitude saying like, okay, I want it to be above my custom horizon with an offset of 5, but at the same time, I want to wait until the object is above 30 degrees of absolute elevation. That way, we're sure we have the correct altitude for my target when I start imaging it. And so custom horizon together with the sequencer in Nina gives you a lot of power to really control when you want to start imaging your targets so that you have like the best compromise of altitude, which gives you better signal to noise ratio, especially in light polluted cities. And yeah, I think it's a really cool feature to have, and it's the kind of stuff that I would love to have in the ASIAir. And one more thing on this general tab is the Sky Survey cache folder, which has a default value that is not where we put the cache. So you can just click on those 3 dots, and for me, I had put it under Documents. I'm just going to put Framing Assistant Cache, select folder. So now this is set up, which means that if I go back to my Sky Atlas and select whatever targets, let's say M31, here we go, we now have some image of M31 on the target. Anything like really should have some images in there. So we have some idea of the image that we're taking. So Caldwell 11, that kind of stuff. So now it's installed and ready, and we can use that in the Sky Atlas to have a good idea of exactly what we're imaging. Then we can go to the Equipment tab. The Equipment tab is important because that's where you have your camera settings. You want to make sure that they are correct. So in this Equipment tab, you have your camera settings, but you also have your telescope settings. So I'm just going to say this is the CS150. The focal length is 570 millimeters. The focal ratio is f3. Which is actually 3.8. And the most important thing here is the focal length, because that's going to be used in Platesolving. And another very important thing that's used in Platesolving is the pixel size. Typically it gets it automatically from the camera, but if it doesn't, make sure that it is accurate. Then I can put my mount name. This is WD20. And the default parameters should be good, so you don't really need to care about that. Then we have, like, if you want to have like weather within Nina, you can have an open weather map API key. I'm not going to bother with that in this particular guide. You could also connect to an external planetarium software, but again, we haven't installed it. Ascom Alpaca Discover, you can leave it as is. But here, we can change the name of my filters for the filter wheel, which is going to be very useful because I have in filter 1 a dark filter, then it's L, R, G, B, H, S, and O. There I have all of my filters properly renamed. If I quickly go back to my filter wheel, you can see that now they're properly renamed and I can choose a filter to go to. So I could say like, hey, go to the red filter, and it's switching filters to the red filter. I could go to my imaging tab, by the way, and I have here the filter wheel, and I could say like, okay, it's changed to the blue filter, and switching filter, and change to the dark filter. But of course, all of that is fully controllable within a sequence as well. Then we can go into the autofocus settings. Now the autofocus settings, we don't really want to touch them that much right now. We do want, maybe the only thing we can do right now properly is to set a default autofocus exposure time, which is 4 seconds by default, which works for most rigs. I would leave it as is, except for my narrowband filters. I have HSO filters, right? Maybe for them, I will double the exposure time to 8 seconds, just to make sure I have enough exposure time to detect the stars with those filters. And one thing that is very useful with Nina, and we have a plugin that will help us with that, and I'll probably cover that in the plugins, is that we can set up filter offsets. For instance, if my luminance filter is perfectly in focus at position 5000, and my red filter is perfectly in focus at position 5005 in terms of absolute value, then I set them up like that, and if I say use filter offsets there, Nina will basically, if I switch Nina from the luminance filter to the red filter, Nina will move the focuser automatically by 5 steps. And so if you know the exact focus point for each of the filters and you put it in there, including for the dark filter, because if you put 0 in the dark filter, it's going to be a disaster. So you want to put something like same value as L for the dark filter in my particular case. But you put all of the values in there with filter offsets. It means that you can switch between filters. And if you were properly focused to start with, as you switch between filters, you will not have any need to do further autofocus. It will just move the focuser by the exact number of steps required to still be in perfect focus with your next filter in the sequence. So that's great because if you're in a sequence, instead of doing like 2 hours of L, then 2 hours of red, then 2 hours of blue, etc., you can do 1 luminance, 1 red, 1 green, 1 blue, back to 1 luminance, red, green, and blue without doing any autofocus in between because you're able to just use these filter offsets, and it's very, very powerful. And there is a plugin that lets you actually compute the offsets automatically and set them up in there automatically. Also, once you use filter offsets, you can say that the luminance filter should always be used as the autofocus filter. So I can select the luminance filter, click on Set as Autofocus Filter, and what is going to happen is that, let's say I'm doing SHO, actually I just realized my my filters are incorrect. It's going to be SHO, not HSO. Boom, there we go. Let's go back to autofocus. But let's say I'm imaging with hydrogen. I'm imaging with hydrogen throughout the night. But I do an autofocus. Rather than waste the time doing very long exposures for autofocus with the hydrogen filter, Nina will go to the luminance filter, do the focusing with the much shorter exposures with the luminance filter, and then go back to hydrogen alpha using the offset to make sure that we're still in focus. It's very powerful, and I do believe it's a feature that I added to Nina because, yes, I used to be a contributor developer for Nina. One of the other things that I recommend doing while we're on this tab is to set the curve fitting strategy to trans and parabolic. This is the one that I feel works the best. At least for every telescope that I've used, it seems to work the best. And I'm kind of the one who developed those parabolic fitting and hyperbolic fitting in the first place. Another thing that we'll be able to set up later down the road is a backlash compensation method, which is if you know your focuser backlash, you can set up in either direction. By default, it's overshoot, and we'll leave it like that. You'll want to make sure to set up a value that is higher than the actual backlash of your focuser. And typically, for most focusers, I like to put the autofocus step size, which we're going to figure out later on under a night sky. But I take that, multiply it by 10, and put it under out. But we can do that a bit later once we have a starry sky, so I can show you how to really do the final touches on the autofocus for it to completely work. Okay, we don't have a dome, so we can skip to imaging. And under imaging, what I like to change is the image file pattern. Here you can see that it would like put date, then the type of frame, then the frame itself with a certain name in there. And instead of date, I like to have the target name. So what I'll do is I'll just go to this, and you see this date minus 12 like $. I can remove that, and I can search for target name, which is here, and drag and drop target name to the very start here. And now it's going to save target name, type of frame, and then the frame itself. And if you want more information, like the focuser temperature or the guide RMS for that particular exposure, to figure out if you had like exposures with poor guiding, so I could have that in between the exposure time and the frame number. So I could drag and drop the RMS, bam, and set it up here. Now, just by looking at my frame RMS, I can check whether I have frames with really bad guiding, and then delete them before I start stacking them. So that's very powerful in terms of how the files are saved. And then we have the Meridian Flip. So for Meridian Flip, it really depends a lot on your mount. And by the way, it reminds me, there's one setting in PhD2. If you go to the brain, if you go under guiding, you have a reverse deck output after Meridian Flip. And for on-step drivers, on-step mounts, typically it needs to be on. I believe that for Green Swamp server, it also needs to be on, but for most mounts, it can stay off. If you ever see that you have issues with the guiding, especially after the Meridian Flip, suddenly like everything goes haywire, you can set that up. And I believe there's an equivalent setting in the ASIAir. But here we can say, in terms of the Meridian Flip settings, where the default settings are that we are going to do the flip 5 minutes after the meridian, or up to 10 minutes after meridian, depending on what we're doing at that particular time. And we are going to recenter after the flip, and we could also say like, hey, I want to do some autofocus after the Meridian Flip, if that works better for your particular needs. Or you can rotate the image if you have a rotator by 180 degrees after the Meridian Flip, if you wish to do so. So for that to work, you need to make sure that your mount settings are correct in terms of limits, so that If you track through the meridian, you need to make sure that the mount will not hit a limit before 10 minutes after meridian. Otherwise, you may want to set up your mount to stop tracking 5 minutes before the meridian. There's all sorts of stuff there. It really depends on your mount, but I recommend doing some tests during the day to make sure that the meridian flip is going to work, or wait until there's a full moon so that you don't really waste imaging time, and under the stars you make sure that the meridian flip works, and you just like slew to a star that's about to go past meridian, start a sequence, see if the meridian flip works, and if it does, great. If it doesn't, change it until it starts working. That's probably one of the more delicate things, and it depends a lot on your mount and your mount settings, but I guarantee you can get it to work. Like the easiest to make sure that it always works is that you can say like pause 5 minutes before meridian and then flip 5 minutes after meridian. That's typically going to work fine as long as your mount limits are okay with that. That is the settings that I recommend if you ever have issues with the meridian flip. I like to set that to 0 because then it doesn't pause at all and it keeps imaging through the meridian. And the meridian is the best quality of images that you get, so I don't like wasting that time. And I'm set up so that my mount will keep tracking through the meridian while exposing, and then Nina will do the flip between 5 and 10 minutes after the meridian has been crossed. Now, all of the settings for now we can leave as is. You can, if you ever have trouble with autofocus, change the noise reduction there to normal or even high, depending on whether you have issues, but the default settings should work reasonably well. Okay, and now we can go to the last step, which is plate solving. And plate solving, you can see that it's set to ASTAP by default, and you can set your exposure time, like let's say 4 seconds, for plate solving, and you could also select a filter that you want to use with plate solving. And if I recommend using the luminance filter, if you have a filter wheel and you've set up your filter offsets. If you don't have filter offsets, just select current, and that's going to be fine. You could change the gain as well of your camera if you needed to, and you can also change the pointing tolerance, like how many arc minutes of error are you allowing. But typically those default settings work perfectly fine. And the only thing you need to do is for ASTAP, it's preset. So it's like I've already got an ASTAP installed, the catalog installed, ASTAP is set up there. Plate solving is basically ready to go, nothing to do. And you could also, if you're using Platesolve 3, you would need to just select the Platesolve 3 file location where you installed it, and make sure that you select Platesolve 3 in both of those boxes. But for us, plate solving is ready to go without us doing anything in particular. And now we can go to the next tab, which is the plugins tab, and this is where third-party plugins are available for Nina to make it even more powerful. So we can click on available. It should list a list of plugins available. For instance, if you want to control your Nina instance remotely using like third-party smartphone apps, for instance, you could install the advanced API. If you want to do polar alignment from Nina using 3-point polar alignment, you want to go to this 3-point polar alignment plugin and click install. If you want to be able to connect and disconnect your equipment within a sequence, you can go to a connector and click install. If you want to have a tool that will compute your filter offsets automatically, which I do, you want to go to this filter offset calculator and click on install. If you want an alternative autofocus algorithm called Hocus Focus, you can click on that and click on install. And each plugin has its own kind of instructions in there. And you have some other cool plugins, for instance, Remote Copy, that lets you automatically copy the files that Nina saves to a remote computer on your network for processing directly afterwards. And all sorts of plugins are available. I'll cover a few more later in the video. Once you've installed them, you can click on Requires Restart. This will restart Nina, and you'll be able to access your plugins. So for instance, if I go to imaging, you'll see that in the top right, I have more icons than I used to have. And one of them is this icon, the 3-point polar alignment. So I can add that And we have it available here, and we can use the 3-point polar alignment for Nina to polar align our mount. Another of the plugins, you can see if I go to the options and imaging, now I have star detector, annotator, and autofocus. I can choose Nina or Hocus Focus, the new plugin that I installed. Others are available within the sequencer, so we'll look at that in a moment. One of the other plugins that I really like, by the way, which is available in the sequencer, is the Orbiculum plugin that basically lets you tell Nina, like, hey, image this target until the next target in the sequence is above 30 degrees above the horizon, whatever, something like that, right? So that it doesn't depend on the current target, but on the visibility of the next target. There's something very similar called target planning that lets you completely let Nina take over everything, and you don't need to create sequence anymore, but we won't cover it right now. It's a very advanced plugin, and it lets you be really, really lazy. Okay, so that's it for the initial Nina setup. Next, I want to wait for a clear night so I can show you how to set up the autofocus, how to do plate solving, how to do my first Meridian Flip, my first sequence, etc. There's a lot of stuff to learn and to have fun with. So let's keep going on that. And by the way, obviously, this is a lot of work, so if you want to support the channel, you can like the video. It really helps it out. And if you have tips and tricks on Nina, you can go down in the comments, or your favorite plugin, whatever. Let us know down in the comments. I'd love to see your thoughts. And if you want to support the channel even more, and you're planning on buying anything from Amazon, including non-astro stuff, Agena, High Point Scientific, etc., if you do so after clicking one of the links down in the description, it will help me out at no cost to you. And if you want to sponsor those videos, make these videos possible directly, you can become a channel member. This is the join button next to the subscribe button, or you can become a Patreon supporter, and I have the link down in the description. Some of my Patreon tiers have access to my videos early and without ads. And you guys, you know it, you make all of this possible. Thank you so much for your generosity and for your support. Welcome to part 2 of the ultimate guide to Nina. And in this particular part, what we're going to look at is calibration frames. So how I take my calibration frames in Nina, and we'll also look at the advanced scheduler, and that lets you control Nina to a very fine grain extent and really completely automate everything about Nina and all of your flows. And of course, we'll look quickly at the framing wizard as well, because we'll use that to add our targets to the sequencer. So with that, let's get started. Okay, so I am in Nina, and you can see I'm on the equipment tab, and I have all of my equipment basically connected. You see my camera is connected, and I'm cooling my camera. Actually, I'll do it to minus 10 degrees Celsius, right? So just cooling my camera there, and that way I'll have it with the exact same settings that I use during my imaging nights as well. So you can see I have my gain of 80, my offset of 8, USB limit of 40, full resolution. This is exactly my parameters when I image. And I'm also putting it at the temperature that I typically image at, which is minus 10 degrees Celsius in winter, spring, and fall, and minus 5 degrees Celsius in summer. But here we're at minus 10. I also have connected my filter wheel, which will be important for flat frames. But if you're not using a filter wheel, if you're just using a filter drawer, for instance, you have a one-shot color camera, or you're using something like Hyperstar, I recommend actually doing something which would be to use a manual filter wheel from Nina. You always have it in this list, manual filter wheel, connect it, and you can actually set the filter names as usual in your options equipment in there, and that will let Nina actually tag each frame that it's taking with the correct filter. So you can just change your filter manually, let Nina that you have changed the filter, Nina will validate that, and then put that information in the frames it takes. That way, when you have taken flat frames and light frames with the same filter, they're properly tagged with the same filter, and therefore they will be matched automatically by stacking software like PixInsight. It's super convenient to have this in place. For me, I'm using a monochrome camera with an integrated filter wheel, which is the QHY Minicam 8, and integrated filters as well, so I don't need to use the manual filter wheel, but we have that available. So how would I take my calibration frames first? So I have actually an entire video on the topic of taking calibration frames, as well as which calibration frames you need for what type of camera. I'll put the link of that video up above and down in the description. If you really want to go in depth, I highly recommend that you check it out. I made that video in a way that it should be understandable even if you're a complete beginner to astrophotography. But for me, I'll just give you the essentials of how you can take your calibration frames in Nina. So let's start with the simplest frames, which are bias frames and dark frames. Right? So bias frames, they're very short exposures on your camera sensor that let you characterize basically the read noise fixed pattern of your sensor. And you have dark frames that are the same length as your light frames for exactly the same settings as well, just like the bias frames. And they're made to really remove the fixed pattern noise of the dark current that accumulates as you take a longer and longer exposure. For me, because the camera that I use does not have any amp glow, I just limit myself to bias frames, but the way to take bias frames and dark frames is exactly the same. You can do it via a sequencer, but because you can just take your bias frames, take your dark frames, and then reuse them over and over and over for months on end, I've never found it necessary to really automate the process. I do it kind of manually. That way I can keep full control and see if anything is going wrong. And what I do is I go to my imaging tab. I make sure that I can see the image, and my bias frames, typically I take them with 1 second exposures because I'm using a cooled camera, and a 1 second exposure at -10 Celsius and a 0.0001 second exposure at -10 Celsius, they're basically the same thing. That said, there are some cameras that have trouble with exposures under 1 second long, and so I prefer to just take my bias frames with 1 second. So I would take first one exposure just to see what's going on there. And you can see I have a proper dark frame. The dust cap on the telescope is on, and I also have an opaque filter on top of my camera here, so I have made sure to select that particular filter. So I have like a double way to make sure that I don't get any light leak into my sensor. And then, okay, seems to be fine. What I'll do is I'll simply select the loop option here, click on save, and I'll call my target name bias. Right? It's a very simple way. I don't try to overcomplexify things. I don't try to put them in a sequence. I just do it manually, and then I'll copy that to my processing PC and forget about it for the next year or so. So that's very easy. Or until I change the settings on my camera. And then I click on image, and then I just wait. Simple as that. And Nina will just save all of the images to the folder that we have defined here, which is under documents for my case. And you see, if we go to that folder, I have this bias folder inside, snapshot, and here are all of my bias frames that are being taken. Currently, 30 exposures. I typically like to have 50 exposures for whatever reason. It's more like psychological than anything else. So I just wait until I see something like 50 items, and then I stop it and I'm good. There it is, we have 50 items. I'll just stop it, and I've taken, just like that, my bias frames. If I wanted to take dark frames, let's say that I do some narrowband imaging and I need to have 300-second dark frames. And I haven't used dark frames for years now, but I would just put bias, not dark in there, and just do it again, loop and save, and then come back later when I'm free. I don't put any limit, because then it's like I'm just taking dark frames until I remember that I'm taking dark frames. And I can do that on cloudy nights without any issues. My rig is always ready, and that's it. Very easy, very straightforward, and I just come back and look at how many frames I have, and that's it. So that's for taking this kind of images with Nina. You have the ability to use those loop and save features in there in the imaging tab. So now we have dark frames, we have bias frames. What about the one everybody loves, which is flat frames. So for flat frames, we have the Flat Wizard. And the Flat Wizard in Nina is absolutely amazing because it can do everything automatically, even if you have multiple filters like I do with my filter wheel and monochrome camera. So here is the Flat Wizard, and I'll be doing things again kind of manually in the Flat Wizard, but this Flat Wizard can actually also be used within a sequence. Let's say you go to, I don't know, like the Pleiades in the first target, and you have a rotator in your system. And so you set your framing perfectly with the perfect angle, but then during the same night you want to go to another target like the Horsehead Nebula, and you set your rotator to another angle, and then after that you want to go to, I don't know, the Rosette Nebula, right? And you get yet another angle. So now you end up with your rig having taken light frames at different angles of rotation. And so theoretically, you need flat frames for each of those angles. You could wait for the night to end to just manually, tell the rotator to go back to each of the respective absolute angles, and then, use the Flat Wizard, which is what we're going to do now. Or you can have an automated Flat Wizard run at the end of each of your targets within the sequence, so that when you wake up in the morning, you have not only your light frames, but you also have your flat frames for each of your angles and targets, and it makes everything so much easier. So going back to the Flat Wizard itself, you have some parameters like the name of the target if you want to have like different names for different sets of flat frames that you are taking. For instance, you could put the rotation angle of your rotator in there, and the number of flats to take by the wizard. Typically I like to put 20, again psychological, I'm sure 10 is fine. And it can also take at the same time flat darks, or dark frames for your flat frames, which may be necessary if you're using something like an uncooled camera. But for me, I don't bother with that, so I don't have this. And you have then the options to have like the open the cover for darks. You have a wizard mode, which is dynamic exposure, dynamic brightness, and sky flats. And for me in particular, I have attached to my equipment a specific flat panel that is always ready and available to use. It's a flip-flap kind of RB Focus Excalibur flat panel, and I can adjust the brightness of that flat panel. So I can decide that, hey, I want to take my flats with 1 second exposure long, and I'll just adjust the brightness of my flat panel until it matches the exposure that I want. And one way that you could do this is manually. Again, we could go back to the exposure, and let me quickly add, this is the flat panel controls. I'm going to add the flat panel controls to Nina, and I could turn on the lights of the flat panel. I could set the brightness to some kind of low brightness value, 10 out of 4000. Say set, take a 1 second exposure. Make sure I'm on the right filter. So change to the lumens filter, for instance. Take a 1 second exposure, and then we look at how it looks like, and I look at the histogram, and basically I want a histogram value that's roughly at 30%, so that would be a mean and median around 20,000, because the maximum for my sensor is 64,000 effectively. So I could say like, okay, this is not enough brightness, so I could try to increase to like 15 and set that, and take another exposure once the brightness setting is done. Let's take another exposure. Okay, now it's too bright, so maybe I'll go to 12, set. Okay, it's almost there. Maybe the best value is going to be 13 for my target of 1 second exposure, right? So that's likely the target that I need, 13. Let's look at the histogram, and yeah, we are exactly where I want it to be. This is the perfect flat frame for my luminance filter. And again, I could do it very manually and go in my loop and save, and then do flat L, something like that, right? So that's possible. And actually, when I use a flat panel where I need to manually adjust with a knob the brightness of the flat panel, I do this first step just to find manually the proper brightness, and then I go back to the flat wizard. But in my case, because I have everything controllable by USB, I don't need to do that. I can just set my wizard mode to be dynamic brightness, which tells Nina, please adjust the brightness of my flat panel until you find a brightness that sets my exposure desires to within what I have in these settings. So I would say dynamic brightness in there, and I would say that my target exposure time here is 1 second. And then my histogram mean target is actually not 50%, which I think is too aggressive by default in Nina, but 30% with a tolerance of 20%. With a tolerance of 10%. So anything in between those two values will work, which means that Nina will probably go for brightness of 12, actually, but we'll see. And before I do that, if I'm using a manual kind of flat panel that I need to put on top of the telescope and make sure it holds there via gravity, I can have Nina slew the target or slew the telescope to point straight above, straight to zenith, so I can plop my flat panel on top of my telescope. But this is not necessary for me, so I'm not doing it. Actually, right now my telescope is under a cover and it's raining outside. So I wouldn't be able to do that. So I will not use this slew to zenith. But you know, by default, you would just keep using dynamic exposure. You can also use sky flats, and that will basically work automatically as well. But for me, in this particular case, I'm going to go for dynamic brightness, and I could say, okay, I want to do it for my luminance filter. The binning, gain, and offset will be the default ones that I have set up in the equipment tab. The minimum flat panel brightness is going to be 0, and I could say like the maximum is going to be the real maximum value of the flat panel, but I know that it's a luminance filter on a fast telescope, so it would never go up that high. I'll just put 1000. It doesn't really make any difference, but it helps Nina find the right level of brightness more quickly. And then my exposure time, 1 second, and then those my target mean of the histogram in there. If you were using dynamic exposure, instead you would have like your flat minimum exposure, which for me would be something like 1 second. Maximum exposure would be 2 seconds, and then I would have the a fixed brightness for my flat panel. But if you don't have a USB controllable flat panel, you wouldn't get this field there. And then Nina would vary the exposure times until it finds an exposure time that fulfills my targets. You can see the difference between those. And then I could just click on play. Here I want 1 second. Click on play and let Nina do its stuff. And we'll see at the bottom what it's doing. It's like setting the brightness to 500, taking an exposure, looking at the histogram, it sees that it's too much, so it lowers the brightness, like halves it every single time until it goes back to a brightness level that seems to make a bit more sense. Now it's already at 31, now it's at 8, and it went to 12, exactly as I predicted, and it's now taking my flat frames. I don't have anything to do. So I can just wait until it's done. Actually, don't really care right now, so I'm just going to stop it. You can see it's taking the flat frames, and the flat frames are at the same time appearing in my Nina folder, the flat wizard there. I have my flats. I have some old ones from April, but I should have the more recent ones in there as well. There they are, 5/29, and actually, yeah, we've taken all of the flats. But you can see that with that, I would need to manually go through each filter, click play, wait, and then go to the next one, click play, wait, and then go to the next one. This is a drag. This is too difficult for me. I need to be more lazy. So we have the multi-mode. So multi-mode is if you have a filter wheel in particular, this is going to be super useful. And you can see I can go to, I can say that, yeah, I want to take flats for every single one of my filters. And I can set my default settings per filter. Unfortunately, it doesn't seem to inherit the settings that I have in the single mode. I wish it did, but otherwise I can just say like my exposure time is 1 second for luminance, and then do the same for red, then do the same for green, then do the same for blue, etc. I would need to set up just those values for each and every one of them. Would be nice if I could just like copy in between, but I don't think that's currently possible. And then when I'm ready, I would click on play, and it would do exactly the same thing and just cycle through the filters, find the right brightness from my flat panel for each of the filters, or the right exposure length if you're using like a given brightness of your flat panel, and take those 10, 20 flat frames and then go to the next filter until it's done, and it's absolute magic. And that is how you would be using this Flat Wizard tab within Nina. It's very powerful and it makes things really easy, especially if you have a monochrome camera. And let's go next to the Sky Atlas and the framing tabs that we have here. And those will be a nice intro because they will very naturally link to the advanced sequencer, which is like the pièce de résistance. It's where really a lot of the Nina magic can happen. So let's go to Sky Atlas. And Sky Atlas, this is something that I introduced already in my previous video. And you can search for specific targets. So Andromeda, there it is, my Andromeda galaxy. And just like I showed in the previous video, we can see there is a line there that tells us the elevation of that target for my particular site at any given time of the night. And also we have the greenish curve there that tells me where my actual horizon on my balcony is located. So for me, Andromeda will only get above horizon when it's already light outside, because in this season, it starts getting bright at like 3 a.m. Thanks, Japan. Yeah, that's one way of looking. You know your target, you just look for it, and you're good with that, right? So that's first way. Maybe, let's see, North America. Like if I search for North, there it is, North America Nebula. That one I should be able to start imaging from like 1 a.m. Although it's raining, so I won't be able to image, but you can see this is a better target there. So we have our little preview there. We have the elevation of the target throughout the night, but I can also do some more advanced kind of searching, where I could say, I want to have the target be at least 30 degrees above the horizon, and I wanted this to be 30 degrees at least between midnight and 2 a.m. That's why I have some actual nice imaging time. I could also set any duration for visible 4, and then click search, and it will find hopefully some targets that would fulfill those criteria. And there it is. We have a ton of targets there that were found fulfilling the criteria. They're fairly rare targets, so the preview there is not as beautiful as it could be, but it still gives us an idea of what's going on there. And you could also filter even more via object type, via like the constellation you want it to be in, the distance from the moon in degrees. So if it's like half moon, you want to make sure the target is at least like, 45 degrees away from the moon, so you don't suffer from the moonlight pollution too much, that kind of stuff. And that lets you, and also apparent size, if you're looking for a specific field of view that would work well for your telescope. So it's actually a fairly powerful way of searching for targets that you want to image, although most of the time I'd still be using third-party services like Telescopius, that kind of stuff. Okay, but going back to the North American Nebula there, let's say that I actually want to image that. I could just add the target to sequence using the default central coordinates of that, but more often than not, I would actually set it for the framing assistant. So I'm going to click on set for framing assistant here, and this will immediately move me to the framing tab. There it is. And what it is doing right now is there's this loading screen there. It's actually downloading a preview of the overall field of view around that particular target from the internet using this Hips to Fits Sky Survey source. And there it is. We have the North American Nebula with how it would look like with the center of the, with the coordinates as given by the Sky Atlas. And you can see that my field of view there would not have been great. I probably would go more to something like this. This is a bit more thrilling, isn't it? And if I feel like, this preview image is not wide enough for me to really decide. Maybe I see like, oh, there's the Pelican Nebula there. I want to see a bit more about what's happening there. I could say that my field of view, I want it to be 4 degrees and load the image again, and I should have a slightly larger field of view in there to really figure out what's happening. And here it is, and you can see it has actually reloaded around the field of view that I have moved around. So you can keep basically panning and scrolling through those images by just like recentering and then loading the image again with whatever field of view you really prefer to figure out exactly what you want to image. So it's a very powerful feature. And you can also double check your parameters about your camera, and those parameters are loaded from the equipment tab here under options. And so that's why I insisted previously that we needed to have the focal length and the pixel size properly set up so that the framing wizard can work really well without any issue. Okay, one of the things that's missing here though is the rotation of your sensor. And if you know the rotation of your sensor because you have a rotating device like a rotator, the ASIAir from ZW, it will kind of be put there automatically. If you don't know, what you want to do is slew the telescope towards this target roughly. So I would click on slew and center. I'm not doing it right now because my telescope is under cover and it's raining. But you would slew and center, and then you can click on determine rotation from the camera. This would take an image of the area, do some plate solving, which we'll learn later how to actually do and set up properly in Nina to make sure that it all works. So once we have a starry sky, so I can show you that, and then it will determine the rotation of the camera. For me, my camera rotation is actually around 90 degrees. So my field of view actually looks like this. And that's, I know, because I've done it a lot of time. But if you don't know, just slew towards the target, or really any place in the sky that's away from the celestial pole, and then click on determine rotation from camera, and it will figure it out, set it up, and then you never need to really touch it again. So there we go. We have our field of view, and let's say this is exactly the field of view that I want to image. And so my next step would be to add the target to the sequence. And so let's see what happens when I click on this add target to sequence. You see I have the choice between the legacy sequencer, which I have not used in years and I have no longer any idea how it works, or what I would really recommend using, and the only thing I will really teach you about in this video, it's the advanced sequencer. And you can see that we have several kind of templates that are available. We have the deep sky object instruction set, the basic sequence target, and my template LRGB. And I'm going to start maybe with, let's try my template LRGB. And as soon as that happens, we are redirected to the sequencer screen with some very specific settings for an LRGB type of imaging with a monochrome camera. And don't worry about how complex this all seems. We're going to go and look at everything and really understand everything together. It's going to be amazing. But before we do that, let me go back quickly to the framing wizard because we haven't looked at everything yet. And I'll also want to show you a bit about mosaics, right? If you want to take mosaics, you would be doing something like 2 horizontal panels, 2 vertical panels, maybe like even something like this, some crazy field of view like that. And you can also choose the amount of overlap that you would want between your panels. I would always recommend at least at least 15, 20 is a good value. So we have a good value there. And you can see that now we have the list of the mosaic panels that you would need to take to really have all of this field of view in there. Now, I personally don't really like taking mosaics. If I'm going to take a mosaic, I'll just put in a larger sensor on my equipment. I'll just go for a smaller telescope like this guy here. That way I can take the whole target at once without having to care about a mosaic. I won't have as many details, but then most of the time I would be looking at the overall image rather than zooming in. So that's where I have like a kind of a different philosophy than a lot of people, but I understand that mosaics are fun. So definitely it's something that you can do. And if I want to add every single one of those panels to my sequence, so I take the image of that mosaic of the North American Nebula and the Pelican Nebula in particular throughout the night or multiple nights, I would click on Add Target to Sequence, Sequencer, and just to show how it looks like, I could also do like the basic sequence target as the template instead. And you can see that now it has added in my sequencer all of the panels that we have with a sequence for each panel that we can go ahead later and modify. So that's how you would be using the framing module in there that also will take care of your mosaics. Okay, but with this framing wizard, we've used Hips2Fits Sky Survey there, and that downloads the data from the cloud. What to do if we're completely offline? Well, actually, you don't really need to use Hips2Fits Sky Survey, because remember that we downloaded a lot of data of Sky Atlas data, the thing that lets us get all of those images in the Sky Atlas. I put that in my documents, and remember that under the options general here, we set up the Framing Assistant cache. Framing Assistant cache, which means that actually if I go to back to my framing, and I go to another target, let's say M42, and that I haven't loaded the image for yet, and instead of Hips2Fits Sky Survey, I use Offline Sky Map. For instance, I can click on Load Image, and immediately, poof, we don't get anything from the internet. We just load the image from the cache that we have downloaded. So actually, most of the time, it's going to be faster to just select Offline Sky Map rather than the Hips2Fits Sky Survey, unless it's been updated for some reason. But really, most of the time, just use the Offline Sky Map and you should be fine. And then everything is just as before. Okay, and so with that, we've understood all of the calibration frames, we've understood the framing wizard, how it's linked to the Sky Atlas, how we can do mosaics and put things into the sequencer. So now is the time to go ahead and check out how this amazing sequencer works and how to make full use of it. So let's go. This thing around here, right, the Pelican Nebula, that's my field of view, I like this. Okay, and now I have the option to slew and center, or you can add the target to a sequence. Now when I click on Add Target to Sequence, you have the legacy sequencer, which I've actually not really used for a few years. And you have the advanced sequencer, and that's the one I really recommend using. You might have some trouble like wrapping your head around it for like the first 10 minutes, but afterwards you'll really get it, and honestly it's absolutely amazing. And in there, there's multiple options. You have like this deep sky object instruction set, basic sequence target, mono sequence, sequence template, and those are in capitals. That's because I have added those manually as my own custom templates. And I've chosen the naming convention simply to put them in capitals. That way I know which are custom and which are the normal ones. And where are they coming from? Well, I can go to the sequencer, click on Advanced Sequencer here, go to Templates, and you can see we have the default base templates. You have a basic setup sequence and a basic sequence startup, and then a basic sequence target. And that's what basically it's suggesting to use. We have my also templates there that are for the proper imaging side of things rather than before a sequence or after a sequence, which are the mono sequence and sequence templates. So this is where this is coming from. So going back to our framing wizard, I could say add to sequence, and I'm going to use one of the default templates, which is what I would highly recommend you start with, which is the basic sequence target. So you can see exactly how things are going to work. So I'm going to add basic sequence target, and you can see immediately we have at the very top something that's very familiar, right? We say that we're going to image the North American Nebula. It's filled in the coordinates from the framing wizard automatically. You can also set a rotation degree if you have like a rotator device. And then we have my custom horizon. We have the altitude of the object, so when it's going to be visible. And we have the dusk and the dawn there, those light areas here. So the x-axis here is the time, the y-axis is the elevation of the target, The green area is my custom horizon. The whitish gray is the normal dusk, civil dusk, and civil dawn. The darker gray is like the astronomical dusk, astronomical dawn, and the black area is proper darkness that we have. So we have all of this information, and then underneath we get to the meat of it. We get to what we are going to be doing. And the first container you'll see, and you'll understand what a container is because we'll really get to it, is this exposure info thing here. And you can just like go through it sequentially for now. So we have some annotations. They're just comments about what this will do. So yeah, we're going to center, we're going to do this, we're going to do that. It just gives you information about what the sequence is about. It's just for us humans. When I use this sequence, I know what's going on. And then we have the first instruction that says slew, center, and rotate. So it would just slew to those coordinates, center them via plate solving, and then still via plate solving, match the rotation angle that you want to have here. Simple enough, right? And then the other instruction in there would be to run the autofocus. Okay, that seems fair. So we slew, center, and rotate. Then we do an autofocus to have precise focus, and then we start guiding. Now we're on target, we're centered, so we start the guiding. Okay, cool. So that's like the first three instructions, and it makes a lot of sense to me. And then we would go to the target imaging instructions. And this is another container there. You see this little box there in here, and we have triggers, loop conditions, and instructions. And here we have just a series of triggers, and it basically tells me like, okay, while you are doing your stuff, which is basically the instructions in here, while you're doing your stuff, if you need to do a Meridian flip, do a Meridian flip. Okay? If you see that the size of the stars in my images have increased by more than 5% consistently within the last 10 subframes that I've taken, then trigger an autofocus. Or if you see that we've changed the filter, trigger an autofocus. So those are just like stuff that Nina will kind of do automatically based on certain conditions, and can be done out of order with the rest of the sequence. And it applies to anything that comes within it. And within it, you can see that we have this box there. I can retract it or expand it. And within this box, we have those trigger defined. And then we have loop conditions that are not defined. Okay, so we're not going to loop this box. And then we have instructions. And within the instructions, we have interesting stuff. And those will be run basically in sequence, one after another, except when they're interrupted by triggers. So here we're going to say, we have one instruction, which is itself a container that says take 20 exposures of 300 second exposures. And that box itself, we can look directly at the instructions. It says switch the filter to whatever. Right now it tells me current filter, so it's not going to change the filter. But I could say like, yeah, switch filter to luminance, for instance. And then take exposure of 300 seconds. It's going to be a light frame, binning 1 to 1. And then the gain is whatever is set at and the offset, whatever is set at the camera level. So we're doing those instructions. And at the same time, within this little box, we have a further trigger that says that we're going to dither after a certain number of exposures. And so then we can see that while Nina is going to switch filter and then take an exposure of 300 seconds, we are going to double check the Meridian flip, the autofocus after HFR increase, the autofocus after filter change, and then the dither after exposures. So for instance, if my filter at the very start was my red filter when I started the sequence, it would have run an autofocus here with the red filter. And now that I reached this point, I would be switching to my luminance filter, right? So we changed the filter. So wait a second. We have this trigger there that would be triggered by this change and say like, oops, no, let's run an autofocus. So effectively, after this instruction to switch the filter, we have, boom, autofocus done, and then we'll go to the next instruction, which is to take the exposure. And then we have a further thing in there, which is a loop condition, where we're saying that we're going to loop for 20 iterations. So 20 times we'll be switching to filter luminance, then taking an exposure, then switching to filter luminance, except that it's already at luminance, so we don't do anything here, and then we take an exposure, and then switching to filter luminance, but we don't do anything there because it's already at luminance, then take an exposure, then switch to, you get the picture, right? So we're basically not switching the filter anymore because we're already on luminance, so we're not triggering the autofocus after filter change anymore, and we're just taking a 300-second exposure each time, and we do that 20 times. And every 3 frames, there will be a trigger that comes up and that says like, hey, we need to dither here. So let's say did these instructions once, so we have 1 exposure, twice we have 2 exposure, thrice, 3 times we have 3 exposures, and before it goes back to the loop, the trigger will be triggered and we do a dither first. And then we keep going. And while we're doing that, maybe after 10 exposures, suddenly the conditions to do a Meridian flip are met. And so this trigger there, that is in one of the containers. So it takes also effect in there. So it's like all of those triggers at the upper level are inherited by the lower level, effectively. So we would be doing a Meridian flip. And then we'd keep going. So triggers are just like basically interruptions based on a set of conditions. Loops are just loops, and there are all sorts of types of loops. And then instructions are just instructions done in sequence, except when we say they're done in parallel, and we'll see that a bit later. Okay, so let's say that I've done my 20 exposures there. What comes next? Well, we still have some instructions left over. We have this instruction at the bottom, which is called a smart exposure. And this smart exposure is basically kind of like a clone of this container, but in a simpler format, where it just says we're going to take 20 exposures of, here it's bugged out, 0 seconds long. No, it should be 300 seconds long, of a light frame with binning 1-to-1, gain is whatever is set in the equipment tab, offset is whatever is set in the equipment tab, and the filter is whatever is currently set, and we dither every 3 frames. Because look at this guy here. This guy here is not in this container. So the dither after 3 exposures does not apply to it. So we would need the dither every 3 frames. That said, this guy here is within that target imaging instructions container. So the Meridian flip and the autofocus after HFR increase or filter change also apply. Let's say that we started with a half flux radius, which is a measure of the star size in pixels, of 3 pixels. And after doing all of those exposures, it's at 3.2. Okay, and then after doing like 5 exposures of this smart exposure, it's suddenly at 3.3 or 3.4. Then the autofocus after HFR increase, and then the autofocus could be triggered there as well. So again, it goes back to those triggers being interrupts for whatever instructions are contained within those triggers. So this is all it would do. There's nothing more. And that would be basically the end of the sequence. But we haven't told Nina anything more. So after the end of the sequence, the mount would still be tracking. We're not telling the mount to stop. So that's it, right? And the mount would keep tracking until it reaches a limit and stops there. So if I had launched this and then I wake up in the morning, I would expect to see my telescope basically stopped at my horizon limit, likely because I've already said the Meridian flip was triggered in this particular scenario. So we have the scope really pointing low to the horizon or below the horizon, right? That's what I would expect to see. And I'd be like, okay, I need to tell the mount to go home again, and then I can put back my cover, etc. So we'll want a way to make this better. But first, I want to touch upon another point, which is what are those big red warning lights or dots or red circles that we have? That looks important, right? This is just to tell me that under my current configuration, these steps will have issues. And why would they have issues? It's because in my current instance of Nina, I haven't connected anything. So I should connect everything. I could connect one by one, just like we did earlier, or I can just use this single button to connect all of the device at once. And you can see it's doing everything. It's launching PhD2. It connected to the guider, the flat panel, the focuser, telescope, camera, and everything is connected. So I can go back to my sequencer and look now, most of those red warning lights are not there, except one slew, center, and rotate instruction still has this issue because if I hover, you can see the reason. The rotator is not connected. So I'm going to have some issues with that particular instruction, right? So slew, center, and rotate, not so good for me. So I have on the left-hand side a list of instructions that I can use. And it's a massive list, and I have some plugins installed that actually add more instructions. And that's all of the crazy stuff that we're able to do in there. It's an insane amount of stuff that we can do. Let's say that instead of slew, center, and rotate, I just want to slew and center. Let's search for slew in there. And let's see, we have slew and center. That's exactly what I need. So I can drag and drop this. I'll put it here and I'll delete that. Bam! So much better already, right? And let's say that actually, I don't want to slew and center first. By default, my home position is pointing towards the north celestial pole. So I have access to some stars there. And so because Platesolving, like centering the target, relies on the stars being roughly in focus, I might want to do autofocus before slew and center. So I can drag and drop this autofocus above slew and center so that we do the autofocus first thing, then we slew and center, then we start the guiding. And because I've never done guiding for this rig, maybe I should force the calibration to be on. And by the way, there's one more thing that goes on in there. There's some parameters that are not visible by default. Is like if you click on those three icons there, sometimes called the hamburger menu, you can open that up and you can see that autofocus, we could, if it fails, attempt it multiple times. And if it fails, we can choose whether to continue, abort, skip to end of sequence instructions, or we have other stuff we can do. And we can also decide that I can disable this. So it's still in my sequence instruction set, but we've disabled it. So I can enable it again. So you can have like anything you want to do in there. And we'll get to this reset arrow once we actually run those sequences under the stars. And if I have something complex, for instance, this guy here, I can make a copy of it. And if I make a copy, then we have a second container there that has been added at the bottom. So there's a lot of things that you can do to use this sequencer. But you can see as is, this sequencer will effectively take 40 exposures of 300 seconds with my luminance filter. That's what we've set it up for. And it will do autofocus at the right time. It will do Meridian Flip at the right time. It will do a dithering every 3 exposures. Although maybe for 300 seconds long exposures, I want to do it every 1 exposure. That's already super cool, right? And but I want to not say like I just exposed for 20 exposures. What are we here? Are we ASIAir users? I'm just kidding. We could instead loop until the target is at a certain altitude. So I could delete that and let's search for some other loop. So I'm going to put I'm going to search for loop. And let's see, I could say loop until altitude below something. So I could say, bam, loop until at altitude below, and I will loop until the altitude is below 30 degrees. And it even tells me right now the altitude of your object is minus 9.53 degrees. It's below the horizon. So this would be triggered right away. But this gives you a good idea of, whether the object will be, how long you would be able to image until it reaches this parameter. So here we're looping until altitude. This, by the way, is the absolute altitude. It doesn't take into account the custom horizon. So I could have something else. I could remove this loop and say loop while altitude above horizon. And I could say okay, I want to make sure it's going to be at least 5 degrees above my custom horizon, while it's looping. And I can actually have those two conditions together. So loop until altitude is below 30 degrees, and at the same time loop until the altitude are above the horizon. If one becomes false, or if one of those parameters becomes like true, meaning like suddenly the target is at 30 degrees elevation or less, but it's still 5 degrees or more above my custom horizon, we'd stop the loop anyway. So that way I can have multiple conditions in there. We can even have some crazy stuff like loop while the next target is below horizon. And this is from a plugin that I installed called Arbuculum. And I showed that earlier. So this is this guy here. It's installed and it gives me those Arbuculum instructions there. And I could say like next target, once it gets like 5 degrees above my custom horizon, stop imaging this current target and go to the next one. So we can look ahead of time and then decide what to do and how much to image. It's all extremely powerful. But most of the time I use something like loop until altitude below 30 degrees because my horizon, my custom horizon on the west side of me is actually very low. So I don't really have any obstacles on the west side of me, and that's where the targets will go. So I'm more worried about altitude limitations before I start a sequence. And that gets me to something else, which is this sequence start area here and sequence end area. So let me go back to the templates, and in your default templates, you will have basic sequence startup. Let me drag and drop it in there. Bam! And you will have basic sequence end. So I can put that in the end area and drag and drop it. Bam! Let's look at what those guys do. So first, basic sequence startup. We have a very interesting stuff is that we have instructions that are set to run in parallel. And you could create your own from scratch by going to your instructions and have like a parallel instruction set here. Bam, build your own thing. So it means that everything will happen at the same time. So Nina will cool your camera to minus 10 degrees Celsius and unpark your telescope at the same time. I could also search in my instructions for filter and tell it like, oh, by the way, while you're there, switch to the lumens filter, because that's probably the filter that I want to use to do all of my autofocus and Platesolving, especially I have filter offsets set up. And you know how I had to connect my equipment until all of those warning signs were removed? Well, maybe there are times when I launch Nina and I forget to connect my equipment, so maybe I want to add like an instructions before all of that stuff here. I could have, this is from a plugin called Connector. So again, if I go to plugins, there's this connector plugin here. I can go to my sequencer and say like, connect all equipment. Bam, let's put that at first. Here we go, connect all equipment. We have it as part of my sequence startup. But I want to put it before all of that happens. So I could even like have an instruction set that will be a sequential instruction set. And within my sequential instruction set, my first instruction will be to connect all of the equipment. And then my second instruction would be this parallel stuff. So this whole block of parallel stuff. There we go. Now we have a nice little real sequence startup. So I could have like my new sequence startup within one block. Except that connecting the equipment takes time, right? So if I connect to the equipment, if I send this command, connect all equipment, and then I try to do that immediately, I might run into issues. So I'm going to wait. And under utility, I have this wait for time span. So I'll put that under connect equipment and say like, let's wait for 30 seconds, because why not? So now we have, Nina will just connect all of the equipment, wait for 30 seconds, then cool the camera, unpark the scope, and switch to the correct filter. And because I also have a flip-flap panel, by the way, I would also want to search for flat, and there you have a flat device thing here. So I want to open my flat panel cover. That way I also open the dust cap. So now it's doing all of those things at once. And that's super powerful. And that is my sequence startup, where I have a mixture, I've built manually a mixture of sequential instructions, so connect all of the equipment and wait, and then perform all of those things at the same time so we don't waste too much time, right? Okay, but wait, that means that I have my all of the stuff, connect equipment, etc., and then I go straight into my sequence. And so Nina would immediately try to run the autofocus, but we're still during the day, so that makes no sense. I need to tell Nina to wait until the target is visible, obviously, right? So let's go to my instructions and say search for wait, and we have here wait for altitude. That's one useful thing. So I want to make sure the target is above 30 degrees. Makes sense to me. I also want to wait until the target is above my custom horizon. So I'm going to put that. Wait until it's above at least 5 degrees above my horizon, right? And I also want to wait until it's actually dark outside, right? So for this particular target, it's going to be dark, right? But it's good to have that just as a matter of principle. So I want to wait for time, and source, you can click there and say, we want to wait until astronomical dusk, and I can even add an offset of like 20 minutes. I'm going to wait 20 minutes after darkness to actually start things. So now if I were to start this sequence, it would get everything ready in terms of equipment, and then it would wait until it's suitable to actually do the autofocus, slew and center, start guiding, etc., etc. And I think you're starting to understand why I said Nina is so lazy, because once you have set up all of that, click play and you can immediately go to bed. You can even use templates to add your targets one by one, like in 2 minutes, click play, and then you don't have to rebuild your sequences every night, that kind of stuff. You can be extremely lazy once you've done the hard work at first. And in my sequences, I actually don't have this smart exposure. I don't need it. I can just keep exposing my 300 seconds exposure. So I can change the description to say like 300 second exposures until altitude too low. Bam, there we go. And that's just with a luminance filter. And that works great if you have a one-shot color camera and you don't have a filter wheel. You'd still likely want to have, as I showed earlier with the flat wizard, to be using a manual filter wheel if you're manually switching filter between like luminance and HA03 and S203, for instance, kind of stuff. That way you can also put that in the sequence. But in my particular case, I have LRGB and even SHO, right? So what if I want to take, L and then R and then G and then B exposures to have all of my color image? The simplest would be like, my intuition would be like, yeah, let's make a copy of this container. And then I'll say like, okay, now that you've done luminance, let's do red. Can you see what the problem with that is? The problem with that is simply that this luminance filter will take exposures until the altitude is too low. So once this is done, it goes to here, and here it just looks at the altitude and says like, hey, you're below the horizon now, so I'm not going to do that. And I would end up with just luminance exposures. That doesn't work. So I need to do something else. I remove that, and I can instead, I'm going to copy my luminance filter and the tech exposure. I'm going to copy those two and keep copying because I want to have everything for LRGB. Okay, I have too many steps there, but I could say switch filter to luminance, then take a 300 second exposure, then switch filter to red, then take a 3 seconds exposures, then switch filter to green, and again take that exposure, and then switch filter to blue, and again take that exposure, and that's it. Okay, so now we would be ready. Can you see what the problem is now? The problem is that we are taking one exposure of luminance, then one exposure of red, one exposure of green, and one exposure of blue. Each time we're switching the filter. So each time, because of this little guy here, we'd be triggering an autofocus. But we don't want to do that. Fortunately, if we've set up our filter offsets, so if I go back to autofocus here and we have those focus offsets, let's say they're all properly set up so that Nina knows where the relative focus point of each filter is in relation to another, we don't need to autofocus in between filters, assuming you also have proper backlash setup, but we'll do that once we're under the stars. So that means that I could absolutely use that and just disable this guy here. So we're not going to do autofocus after filter change. We're just going to go sequentially luminance red, green, blue, luminance red, green, blue, luminance red, green, blue until the target is too low. So that's one way of doing things. But there's other ways we can do something very similar. Let's say I don't want to take as much RGB data as I take luminance data, because luminance data is where the juicy stuff is at. It's where we get all of the details. I want to take twice more luminance than I want to take RG and B, maybe not combined, but each. So let's do that. We could just delete all of that stuff. So one of the ways, then, once we've removed all of those exposures, there's something else. There's like a take many exposures. So I can actually, let me go back and add the switch filter, because we still need that, and say, okay, we're going to switch filter to luminance, and then we're going to look for exposures again, and we're going to take many exposures instead of just one. And I could say, like, let's take 3, or let's say, yeah, 3 luminance filter exposures of 300 seconds long. Okay, then we switch the filter. So I'm going to make a copy, switch filter to red, and this time we only take 1 exposure of 300 seconds, or whatever the time is appropriate. So now it's all working out well, because we're going to get 3 luminance, followed by 1 red, followed by 1 green, followed by 1 blue, I mean if I added green and blue, right? And then go back to 3 luminance exposures. So I'm having like a proper ratio of exposures as I want it. And we'll still dither after each exposure. We'll still loop until the altitude is below a certain altitude, that kind of stuff. So that's very powerful. And if I didn't have any filter offsets, for instance, I could choose to re-enable the autofocus after filter change and use this take many exposures instructions here to say, like, okay, we're going to take first 12 exposures of luminance, then 6 exposures of red, 6 exposure of green, 6 exposure of blue, and we'll still do autofocus after each filter change, because then we have a good amount of time in between filters, and so we're not losing too much exposure time by doing this autofocus after filter change. So that's the difficulty of the advanced sequencer, is that you do need to think about all of the triggers that are being applied and all of the loop conditions that are being applied to your sequence. It can get a bit crazy if you have loop conditions here as well as there. And now you need to think about it even more, because you have loops within loops. Technically, a take many exposure is in itself a loop. So yeah, it's like, it can get a bit like crazy if you do things in a complex way. But the default template really arranges it in a way that things are simple to understand, and there's not too much to think about. And by the way, if you wanted to get even more simpler, I could take those triggers, those 3 triggers, put them there, and then remove this particular set of instructions, because this box here, this level above the 300-second exposures is doing nothing except give us triggers. So it's a kind of useless, but if it works, I'm not going to change it. Okay, so now this, why do I have this connect all equipment? I'm going to remove that. Now we go to the basic sequence end. And basic sequence end is the counterpart to the basic sequence startup. And we can see that the default instructions are to warm the camera and to park the scope. And then also we can run an external script if we want to, because yes, you can create your own super advanced scripts for Nina and run them, but this is going far beyond this tutorial, so I'm going to remove the script part. Now we have again a parallel sequence of instructions where we warm the camera, we park the scope. And actually for me, and for something like the ZW-AM5, for instance, even I think the WD-20, they don't really like being parked. I think the AM5 has a weird parking behavior for me. So instead of park, I tell it to go home. So I can search for home in my instructions, and I can say find home instead of park scope. So warm the camera, find home. I also want to close the flat panel. So I can, flat panel, where's my flat panel cover? I'm going to close it. Close the flat panel cover. And then I can also disconnect all of the equipment. So I'm going to search for disconnect. Yeah, disconnect all equipment. And do you see what the issue is? I think you do. It's that now all of these instructions they're run in parallel. So if I'm trying to disconnect the equipment while I'm telling the telescope to go home and while I'm closing the flat panel cover, which one will be faster? Will I have disconnected the equipment by the time I'm trying to close the flat panel cover? We have a conflict there, so we need to be careful, and this disconnect all of equipment should be underneath here. There we go. I might even want to be careful and just add a wait for a certain time span, which is here, drag and drop it here and say we're going to wait 30 seconds after we've done all of that to make sure we're properly home. Everything is closed, everything is done, we're happy, and then we disconnect all of the equipment. So you can see I'm really starting to create my stuff really well. And by the way, if I had multiple targets, let's say I add another target, M31 doesn't make sense, but I'm going to add just M31, add target to sequence, and select my basic sequence targets. You can see that now we have the North American Nebula first, and then we have M31. And because I'm using the old template, it still has this warning on the rotation. But whatever, it's just for example. I could add something else there that says, I'm going to search for flat again, and search for auto brightness flat. I would say that after this loop is done, so we have the loop going on here, I want to do an auto brightness flat exposure. I want to take my flat frames automatically because I have a flip-flap panel. And of course, before that, I would need to close the flat panel cover and then open the flat panel cover. But you can see, I can say like, hey, take 20 flat exposures with the maximum flat panel brightness of 100. My histogram target would be 30%, just like we did earlier. And my target exposure time is 1 second. And I would need to also keep the flat panel closed, otherwise it would reopen because we need to do it for multiple filters in my case, right? So I need to add some switch filter. Switch filter to, let's say, luminance. And then I'm going to make a copy of that switch filter to red, and then make a copy of the auto flat panel. Bam, there we go. So we have luminance, take your flats, then red, take your flats, and then I can add green and blue, take the flats automatically, and I can add that after each target. And to make things easy to copy in between, I should create an instructions container. So I'm going to search for instruction, say sequential instruction set, add it here, move all of that stuff in the underneath, pam, 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 and pam. There we go. And now I can make a copy of that whole container and also put it small and drag and drop it. I'll first drag and drop it here. And then now I'm ready to put it at the very end of the next target as well, so that I can take my flat frames every single time, which, as I said earlier in the video, is important if you have a rotator. Then you can, at the end of each target, have your flat frames ready for that particular target. And that's all, in my opinion, pretty amazing. And that was a lot of work, wasn't it? So it would be nice if we could save templates, and you know it, I've already shown you, you can save templates. How do you do it? You first set a name onto your container. That's one of the reasons I created the sequential container at the start, even though it didn't look like I needed to do so. And you drag and drop it into your templates. And bam, I have my new sequence startup here. That's super cool. Then I have my template for my targets, let's say I've completely done it, you know, I've added LRGB, maybe some hydrogen alpha, whatever, and then same, I have like all of the flats for my flat wizard. This is the template that I like, so I will say like, you know, I'll name it my awesome incomplete, because I haven't done everything, templates, bam, and I can add it in there. And I can do the same thing for the end templates, and they like my awesome end. That sounds ominous. There we go. And now we have all of those templates that are available. So if I go back to like the Sky Atlas and say add target to sequence, sequencer, what do we have here? We have my awesome incomplete template. And so I can select that, and bam, M31 is added a second time, but with my awesome template, which includes those filters and the flat wizard, because we've created all of that. And that, my friends, is the advanced sequencer. It can get quite a while to wrap your head around, but if you don't need to do complex stuff, especially if you're doing one-shot color, the default template will work amazingly well. So I can delete everything from the sequence, bam. Go back to my framing wizard, go to add target to sequence, sequencer, and select the basic sequence target that comes with the sequence. All I would need to do, or comes with the Nina install, all I would need to do is add basic sequence startup, and that's probably enough for me. Put basic sequence end, and that's probably going to be enough for me. And only thing is I don't really need the smart exposure. I would just select, you know, the number of frames that I want to take with my one-shot color camera. Let's say I want to take 100 frames of 60 seconds each. And I can set filter to current because I have a filter drawer if it's a one-shot color camera. And because I'm taking 60-second exposures, maybe I want to dither every 5 minutes instead. And then the only thing is I don't have a rotator for me, so we just need to replace this slew, center, and rotate by searching for slew and center. There we go. Put autofocus above. Save this as a sequence template, bam, with a proper name. Here it's going to be named North America, whatever. And you can reuse that as many times as you like. It's ready for you to go. That's the only stuff you need to do to have a basic sequence within the advanced sequencer. It's 60 seconds of work. And then you can reuse that again and again until you want to go even more advanced with all of the stuff that I've done for monochrome cameras right now in there. It's some awesome stuff. And if you have a template that you no longer want to use, you can drag and drop it to the trash icon here. It's a very macOS-like experience. And I'm going to say yes. And North America Nebula, I don't really need it either. I'm going to remove that, etc. And as you've seen, plugins add a lot of instructions to the advanced sequencer. If you want to get your head to explode, you can use a plugin that is called Power Ups. But that is going to really make your head explode unless you're really used to the advanced sequencer. So this is this plugin, Sequencer Power Ups. If you have it installed within the sequencer, you'll see that you have this Enhanced Instructions Power Ups. And that's for instructions. And you also have Power Ups Expressions, Power Ups Functions, Power Ups Meridian Flip, Power Ups Miscellaneous, Power-ups, safety. You have all sorts of crazy stuff in there, and you can create variables. Like I can say, oh, I have a global variable, says we're going to define a global variable. It's going to be a dither frequency for narrowband NB, and it's going to be set to a value of 1 because I want to dither every frame. And then I also want to have like a dither frequency broadband, and the value will be 5 because I typically take 60-second exposures for broadband, so I want to dither every 5 frames instead. And then in the dither after exposures, instead of using dither after exposures, I'm going to use the Power-Ups dither after exposures plus. Put that in there, and now I can tell it in here which of my variables to use by setting the variable name in there. This gets completely insane, but you can see that by that time, we're basically programming. We're programming a sequence. We're effectively writing code, but we're just using a graphical user interface to write code. It gets crazy, but you can see that if you're an advanced user, this can add absolutely insane stuff to your sequences. You can do literally anything. Okay, so now I think you understand a bit more the advanced sequencer in Nina, and more importantly, I think you understand how to modify the basic templates to just fulfill your needs in just like 20-30 seconds, and how to make use of it to make it more and more powerful to suit your needs more and more. I think it's an amazing, amazing piece of tech, and I absolutely love using that thing. But let me know down in the comments if you have any questions or if you don't understand something. Like the video while you're at it, you know. And if you're planning on buying anything from Agena, Highpoint, First Light Optics, Amazon, etc., if you do so after clicking one of the links down in the description, it will help me out at no cost to you. You can also sponsor the channel directly by becoming a channel member or a Patreon supporter. The link is down in the description. But anyway, that leads us towards the next part, which will require a starry sky. So yeah, we'll do the test under the stars of first setting up the proper parameters for autofocus, for auto guiding, for Meridian Flip, and then testing out as well a sequence that we build in the advanced sequencer. So all of that in the next part. We're back for the next part of the ultimate guide to using Nina, the free and open source astrophotography software that lets you control all of your rig in a super powerful manner. And for the first time in forever, we have clear skies, although quite like a 3/4 moon, but still clear skies that we can use to do the initial setup of stuff and testing of stuff like autofocus, like what is going to be my step size, what is going to be the setting that I have for backlash, etc. And also things like Platesolving, make sure that it works. Meridian Flip is something we could check as well. And then also things like setting up the guiding from Nina and PhD2 together before we can actually get started with an advanced sequence that will run throughout the night. So I am currently in Nina. I'm on the equipment tab, which is where we normally start our journey when we're in Nina, and I have all of my equipment connected using this connect button here that lets me connect everything at once. And in part one, we set up all of the equipment, and so now all of the equipment was connected without any issues. And my next step will be to go to the imaging tab, because this is where I can control my camera. And I've also set up my tabs so that I can look, you know, at my filter wheel, flat panel, focuser, etc. So I have a flat panel that closes in front of the scope and acts as a dust cap. And it's currently open, so I can actually see the star. And I have the telescope in its initial position pointed at, you know, the North Celestial Pole, more or less. And if you are able to see stars at the North Celestial Pole, you don't have any obstacles. You can use it as I do now, unless it's very low, like you're in Singapore or something like that. That's not going to work. Otherwise, you'll want to maybe first, you know, go to something like manual focus targets. And if you don't have it available, you just need to go to the top right here and click on this star icon, and it should appear somewhere on your UI. Then you can put it in the right place, and then you can choose whatever star is like high enough. Like for me, it would be Al-Qaid, and then slew to that star. And then you can, basically the goal is to get to an area where you can actually, you know, take images of the stars, because now we want to actually get our autofocus parameters decided and settled on. So here I am just towards the North Celestial Pole, and I make sure that I have a filter that lets in a lot of light. So for me, it's going to be the lumens filter, and I can take an exposure. I like to have 5 seconds just to make sure that I'll see stars, even if they're very much out of focus. So here, if I take a 5-second exposure, you can see that the stars are indeed out of focus, but they're not too far out of focus. They could be, depending on your situation, extremely far out of focus, in which case they would look typically like very large, very dim, either like discs or donuts. depending on whether your telescope has a central obstruction. In this case, you may even want to go to like 15 seconds, 30 seconds exposures until you can see stars even as huge disks or donuts. And then your goal is to find the direction of focuser travel that will make those disks or those donuts smaller, so that we can get as small as possible until we actually pinpoint in focus and the stars are point rather than either disks or donuts. For me, because I do have a central obstruction, you can see that it's more or less like a little donut with a dot inside. And so I have already my focuser control here. By default, it's actually on this window. Normally, you have like two tabs in there. You have like the camera and the focuser. You don't have weather. But I decided, to move things around, and I had because I like using both of the tabs, so I put the focuser over weather there, and I never use the weather, so I have the ability to use it here. So it's super powerful customization of the controls that you have in there. So we have the focuser at a specific position that is kept track of by the ASCII driver of the focuser, and it's just Nina reports on it, and you can ask Nina to move to a specific target position. Like we're at position number 5000, we could tell Nina to go to 5050 and then click on move and see what happens. Another way that we can make the focuser move using that is to use the arrow buttons at the bottom here. And by the way, if you do not see this tab, you just need to click on this little plus icon, like, I don't know, plus with like a framing type of icon kind of thing, and that should make it appear somewhere on your UI. Then you can move it around as I just did. And yeah, so I was talking about those arrows. The single arrows will move the focuser by a little bit, and the double arrows will move it by a lot. Specifically, the double arrows will move it by 5 times your autofocus step size, and the small arrows will move it by half the autofocus step size. So there's like a ratio of 10:1 between those two movements. What is your autofocus step size? By default, I believe it's 40 or 50. And this is what we have here under autofocus, and you can see it's indeed set at the default of 50. So it means that with the single arrow, I'll be moving my focuser by 25 steps. Otherwise, with the large arrow, I'll be moving it by 500 steps. By 250 steps, sorry. So that's how it works. By the way, if you don't like the way that those arrows were implemented, it's my fault. I added them to Nina years and years ago using those definitions of half and 5 times. Sorry. Maybe what we can do is try to move in one direction with the large movement and see what happens. So I'm going to choose to move to the right and just do that, just to see the impact on stars. Because the step size, like those, what is one step? How much does it move the focuser tube? What is the impact on the stars? I have no idea at this stage. I'm blind, I'm flying blind. So I just moved it to the right there, and you can see that the position that used to be 5000 is now 5250. So I'm going to take, let's say, 3-second exposure and see how the stars are looking like. I'm even going to zoom in so I can see the change. Okay, so we can see that by going 250 steps to the right, it made a huge change on my stars. Okay, so we want to go back to the left. And also because the change is actually really big there, I feel like I will likely need to reduce the autofocus step size because this is big. Let's see. Let's take another 3-second exposure. We should be roughly, minus the backlash, back to where we started, and we know that we likely need to move the focus still more to the left until we get nice in-focus stars. Although, if your autofocus step size is far too large for the actual movement of your telescope, we might have like skipped across the point of best focus and be on the other side already. We'll see. If by using the left arrow I get more and more out of focus, it means that the best point of focus is between 5000 and 5250. We're doing all of that not to do manual focusing, just to figure out what are the right parameters for autofocus. So let's move to the left with just 25 steps and see what the result is. Okay, so we're getting more and more out of focus, so which means that actually my point of best focus is between 5,000 and 5,250. We went right past the point of best focus. It does tell me that my step size is likely too large. And we saw a large difference between almost in focus stars and now very much donuts with just 25 steps. So that means that the autofocus step size is probably needs to be less than 25 focuser steps. It needs even to be much less, because ideally, if I move the focuser by the number of steps that is defined in the autofocus steps, so for me it's 50 right now, I should see like a small but noticeable change in the star size. That's my criteria. It's kind of a rule of thumb. So I'm going to try something else. I'm going to say, okay, go back to the autofocus step size, which is measured in focuser steps, and say we want to move by, let's say, 20 each time. 20. And then I go back to my imaging tab and I use the small arrow, which will move 10 steps to the left, and I'll just look at the impact on that star. Okay, we moved only 10 steps. I'm going to take an exposure, and we have a small but noticeable change in the star shape with just 10 steps. So that means I think we found our ideal autofocus step size. It is 10 focuser steps. So we can go ahead, go to options and set 10. Now I'm using a very, very cheap focuser called the Gemini, and a single focuser step actually is a large amount of movement. For most focusers like the ZW-EAF or the QHYQ focuser or the Toptec AAF or others as well, typically your autofocus step size, I would expect it to be around 25 to 50. Sometimes even more, like 100 is not unheard of. So 10 is actually a very small value. I expect yours will be larger. But you're looking for a number of steps where you as a human, you can see the star getting a bit larger to a noticeable degree. That's the important bit. So, okay, now we have probably a good step size for our autofocus routine. So I'll just go manually to a better point of focus. We already determined it's like in between 5,000 and 5,250. So I'll just put, yeah, like 5,080. You know what? I'm gonna guess it's 5,080. Let's see, and click on move. And once we are at 5,080, I'm gonna take another exposure, and we are close. We're not quite in focus, but we're definitely close to best focus. The stars are no longer donuts. They're still a bit fat, a bit too fat for my taste, which means we're not quite in focus, but we're close. So now we could run an autofocus to make sure that everything works. But there's one more thing. We haven't set the focuser backlash. The focuser backlash is basically when you change direction. So let's say I move to the right by a large amount, and then I move to the left by a small amount. Maybe when I move to the left, I don't see any change for a couple of times, and then I start seeing change. That's because gears have backlash. So if I take this guy here, like when I change direction, there's a moment where the other gear does not move simply because they're not perfectly meshed together. And that's what's happening in your focuser. It's happening also sometimes at the level of the telescope focuser itself, the tube moving in and out, for instance. So you're looking at the combined telescope plus electronic focuser backlash. And if you don't correct for backlash, your autofocus will not be precise. And I have kind of a magic formula that works for pretty much every telescope and focuser combination that I've tested. And I've tested Schmidt-Cassegrains, Newtonians, and refractors, never Ritchie-Chrétiens. So maybe it's not good for that, but I take the autofocus step size, I multiply it by 10, and I put it in one of those backlash in/out settings. Only one of those. And you may need to make sure that the backlash compensation method here is overshoot. And if it's not overshoot, if it's absolute, you want to go to your equipment tab, disconnect the focuser. I'm not actually going to do it. Go back to your options and then move it to absolute before reconnecting the focuser. But if you're in overshoot, just in one of the directions, take your autofocus step size, multiply by 10, put that value in there, and we may need to change that a bit later on, but for now it's fine. Basically, the goal is to have a value in here that is larger than your actual physical focuser backlash. And I find that 10 times the autofocus step size is a good compromise between like a too large a value and too small a value. It works pretty much every time I've used it. Something like the ZWEF, for instance, you have a backlash setting, but that's only used when you manually move the focuser. The ZWEF autofocus module or routine has a huge backlash compensation built in, which can cause issues if you have focusers with limited travel. Okay, so now we have set those things up. And just remember that when we set up Nina, I mentioned that the curve fitting strategy that I prefer personally, as kind of the one who built those fitting strategies, trends and parabolic. To me, it works really, really well. And you have tons of other parameters. I would always recommend leaving the autofocus initial offset steps to default. The autofocus method star HFR. Curve fitting strategy, again, trends and parabolic works for me. Number of attempts, one works fine for me. I mean, if it fails once, it's usually not going to succeed the second time, but you can increase that. And there's also, like, if you want to use only the bright stars, because maybe you're on a target where there's a lot of faint stars and you feel like the faint stars are betraying the autofocus and making it focus poorly, you can use that. Say, like, just use the 5 top brightest stars. Otherwise, you just set that to 0 to say no. And you also have 2 parameters that kind of should be next to one another, but they're no longer next to one another. The outer crop ratio and the inner crop ratio. This is, if you want, like by default, the Nina autofocus will look at this frame and look at all of the stars and do focus. It's possible to tell Nina, look only at the stars at the center of the field. Or it's possible to tell Nina to look only at the stars within a sort of rectangular donut within the field. So if you want to do that, you would go to this autofocus and you would say, for example, inner crop ratio is like 0.5. So it's a value between 0 and 1. And outer crop ratio could be 0.8, let's say, something like that. Then I'm going to go to imaging options and I'm going to select annotate image so that we see how the focus would work. And I'm going to take an exposure. And here we can see that the stars that have been highlighted there are the stars that Nina would use for autofocus. And you can see they're all in this kind of donut that is between inner crop and outer crop. Like, this can be useful if you want extremely precise focuser, and I'm told that it is very useful for Takahashi telescopes. And initially, I'm the one who implemented this feature as well. If you go back to your autofocus options, and if I set my outer crop ratio to 1, the maximum, and the inner crop ratio to 0.5, now it's no longer a donut. We're just going to look at the frame, something like that. So we're just going to look at the stars at the very center of the frame. One also way to use this outer crop, inner crop ratio is that if you're imaging a globular cluster because of the high concentration of stars at the center of them, they can make the autofocus algorithm kind of panic. In which case, defining a donut outside of the main globular cluster can be a very good idea to make sure the autofocus works well. So I'm going to go back to the default settings of 1 and 1 because we're not going to use this right now. I could set a binning. I like to set that to 1 The R-square threshold is basically kind of a curve-fitting threshold to determine whether your autofocus was successful. I think that 0.7 works well most of the time. Default autofocus exposure time is going to be 4 seconds, and you can override it per filter there. You can see in parentheses you have the default autofocus time, and then for S, H, and O filters I have manually overwritten that to be 8 seconds. You can choose whether you want to disable guiding during autofocus. If you're using an off-axis guider, typically you do want to disable guiding during autofocus, and I do use an off-axis guider, so I'm going to set that to on. And then if you have a focuser that somehow, you know, it needs to settle down before you can take another exposure, you can put a settle time in here. But for most focusers, 0 seconds should be fine. You could also, if you wanted to, for each autofocus point that we're taking, normally we can take one exposure, measure the stars, move the focuser, take one exposure, measure the stars, move the focuser, etc., until we get a nice curve that tells us where the minimum, the point of best focus is. But if you want to have even better results, even more precise, you can spend more time, and instead of taking one exposure per focus point, you can get 2 or 3, and then you average, Nina will average the star sizes, which can, you know, counteract the effects of wind. If you're imaging on a very windy night, it could be a good idea, so that you average out like the artifacts, the poor measurements that can be triggered by strong wind on the autofocus. And then we've already explained the other settings. So that's all of the autofocus settings. And now I can go back to my imaging tab. I'm going to take one exposure with the annotation should be back to basically all of the stars. And if you ever see that at this stage when you're close to focus, the stars are not getting, you know, detected properly, especially if you use the default autofocus time, which is 4 seconds, and the one that you've set up, you could go ahead and go to the imaging options. So let me go to the imaging options, and there we go. And you can see that you have some advanced settings in there with a stretch factor, bias clipping, star sensitivity, and noise reduction. So if you see that not enough stars are being chosen, just increase the star sensitivity. If you see that noise is being chosen, but not like sometimes what is obviously a hot pixel or noise is being chosen as a star, then you want to enable some noise reduction. And if it tends to focus on hot pixels, you want to choose median. Otherwise, you can try normal, high, highest. And the goal would be that can be very useful with uncooled camera sensors that have more thermal noise. So in that case, you medium is the most effective, but it takes a bit of time, especially if you have a slow CPU on your imaging PC. Otherwise, normal or high would work well. If by default you feel that your image is too bright, the stretch factor, decreasing the stretch factor by like 0.05, sorry, so putting it at 0.15 instead of 0.2 can help. If, in contrast, your image seems too dark and you want the stretch to be more aggressive so that Nina can detect more stars for autofocus, you can increase that value. And if Nina picks up noise as stars and the noise reduction didn't seem to help, you could try to increase black clipping from like -2.8 to something like -2. So those are like small things that you can do, but I have not had to do that at all for a long time. I implemented this star sensitivity, this noise reduction, and it's a lot of effort went into that. I analyzed so many images from so many types of cameras, got volunteers to send me like subframes. I mean, it was insane amount of work, and you can really dial in your star detection very well. Just make sure that when you're doing that, you have annotate image on, and you can play with that one parameter at a time to see how well it affects your images. For me, this is perfectly fine. This is going to work great. So I can open the autofocus tab. If you don't have it visible, for me it's here already. But you can click on this AF icon there, and it should become available in your imaging tab. And what I'll do, I'll make sure that autofocus will work, and I'll study the curve, see what happens. Let's do start autofocus. And I'm going to wait and show you how it looks once the curve is done. Okay, the autofocus is done, and we have a curve that is typical of an autofocus run that was started when the stars were a bit to the right of best focus. Maybe we started, here actually, and then we took exposures there, and then we went all the way back and we found the minimum. This is the minimum with the parabolic fitting that tells us it's here. The minimum with the trends, we can't see it here, but it would be around there. And then the compromise between the two is actually the point of best focus. It's this red dot there, and it's perfect. That's why I love parabolic plus trends. It's kind of an autocorrection algorithm between the fitting and the curve, the trend fitting. And it works even when you have a curve that is lopsided like that. If I were to rerun the autofocus right now, we would get my typical autofocus run mid-session, mid-sequence, and let's take it and look at how it would look like, because that's like what we would get in real life most of the time. Here we go. This is what we get. It's not too lopsided. It's okay. We get perfectly the point of best focus, and things seem to be fine. I could probably have the step size a bit larger, because we stay like between 5 HFR and around 3, right? 3 to 5, it's a bit of a small range to be playing with, especially since we saw that we could go a bit further. So I think I'll go to my, my autofocus options and set that to 15, but it should be fine with 10. Now there's multiple symptoms that you could see here. Let's say that you have a step size that is too small. I'm gonna show you how it looks like. So I'll put like an autofocus step size of, let's say, 2 or 3, and show you how that looks like after we do an autofocus run. Okay, so this is the kind of stuff we'd be getting. Basically, it's like there's no curve. It didn't work, and actually it noticed it, and it canceled the autofocus. So we had only a slight glance at it. But when you get like points that are all like kind of all over the place, it's more than likely that you simply don't have a large enough autofocus step size. What about too large of an autofocus step size? Let's say 30, to see exactly how that would look like. I'll go to imaging, I'll start autofocus, and we're going to look at the image as the autofocus routine is running as well. So immediately you can see that we went very, very far out of focus, but Nina is doing a really good job at detecting those stars. And now with each focus step, we are moving, like changing the star size quite a lot in between focus steps. But I'm actually really impressed by star detection. Oh, 666, sorry about that. It's working actually much better than I expected with such a large step size. And this is the curve that we get. It's actually beautiful, but you can see the last point there. There was a lot of uncertainty. The red bar is a measure of uncertainty. I also added that to Nina. So overall, it worked really, really well. I'm kind of impressed. Yeah, we're going from like 3 to 12 in terms of measurement of the star size. That's too much of a spread. So I think 15 autofocus step size is going to work well. So let me do a focus with the 15 step size, just so that we see how it looks like. And here we go. That actually looks like the best compromise. We're going between 3.4, let's say, and 7, 7.5. That's excellent. That's exactly what I need. This is our step size. We're good. And there's one more symptom that I want to show you, because it's also important to recognize. So I'm going to go to the options and remove my backlash compensation and run an autofocus to show you how it looks like without the backlash compensation, or with not enough backlash compensation. Okay, we have a really weird shape there once it's done. It still managed to find the right focus point, but If we go to the final image, which is this, the stars don't look perfectly in focus. This is because when Nina basically moved the focuser to the best point of focus, it actually reversed direction. And so the focus point is off by the amount of backlash in your focuser. And the symptom of that is a curve that is kind of flat at first before finally getting an angle that makes sense. So if you look at this, the left-hand side of the curve is not affected by backlash at all, but the right-hand side of the curve, and that would always be the right-hand side, is affected by backlash. If I look at the slope of the curve there, you can see it's something like this, and the slope of the curve on the right is good up to this point. After that point, it flattens. And effectively, the amount here of steps that were taken, which are 2 autofocus steps, meaning 30 focuser steps, is the native backlash of your focuser. So I know that my focuser system has a backlash of roughly 30 steps measured in focuser steps. So if I wanted to, I could go and say backlash in out like 50. That would work. And yeah, let's try it out actually. Let's go to image. It doesn't really matter. I could keep it at 100. It would work fine. I shouldn't, don't try to fine-tune backlash. If it's working, not a problem. If, however, after setting backlash to be 10 times that of the autofocus step size, and you still see like a flat part there, then you need to increase that backlash number that you had by the number of focuser steps that you see during which the curve is still flat. Let's see if I'm right and that the backlash is indeed less than 50 focuser steps. So I'm going to click Start Autofocus and let's see the result. And here we go. We have a beautiful focus curve with a beautiful point of best focus. It's magnificent. This is exactly what I need. I didn't really need to really fine-tune the overshoot backlash there. The initial value was perfectly fine, but now we're like super optimized because why not? So here we are. And by the way, one more tip. If Nina wasn't able to find stars in there. Actually two more tips. One, when you enable annotate on Nina, the image will be black and white, even for color sensors. So after you're done, you can go back to imaging there and turn off the annotate image. And then the image will be back in color if you're using one-shot color. But also if Nina doesn't detect enough stars and the other settings that we looked at don't do anything, just increase the exposure time for your particular filter. So I could actually go for the hydrogen alpha filter and then do an autofocus to make sure that under my autofocus options, the 8 seconds exposure time that I have set up for the autofocus will be enough to do the autofocus successfully. And let's try it. Start the autofocus. And one thing when you do that is I like using the celestial pole, or I like using a star field at around 30 degrees altitude, because that's kind of the worst case scenario for autofocus and the autofocus exposure length. My own latitude means that when I'm towards the celestial North Pole at 35 degrees, so it's perfect for me in terms of a star field to analyze. But when you're really looking to find out what is your optimal autofocus kind of exposure length, it's good to look at the worst case scenario and maybe find a target, maybe around go back to the manual focus targets and find a target that's around 34 degrees. Slew to it, and then attempt autofocus with one of your broadband filters, one of your narrowband filters with the respective exposure length, and then see whether it works. Bonus points if you do it on a smoky/smoggy day, because that's also a big problem in terms of autofocus exposure time. And your goal would be to find the lowest autofocus exposure time that still gives you a perfect curve, because then you optimize the amount of time that you spend autofocusing in your sequence. Honestly, I don't think it's worth optimizing that much, and I won't try to do it, but that is something you can do if you want to really optimize and spend as little time autofocusing as possible in your sequence. So here we are. The 8 seconds seem to be working quite well for hydrogen alpha. I have a good and autofocus position. Perfect. No issues whatsoever. So I'm just going to keep that. Okay, so we're pretty much done with autofocus. In the next part, I'll be looking at various Nina plugins that could make things even better, if you wish. So I've already mentioned a bit Hocus Focus. I will not focus on the Hocus Focus next time because it's a hugely complex plugin. I've already shown you in a previous part how to enable it if you have trouble with the vanilla Nina autofocus, but one of the plugins that I'll use in the next part of this ultimate guide is going to be the filter offset calculator. So yeah, look forward to that. Otherwise, let's go back to our imaging tab. And once you're done with autofocus and you have your image properly in focus, I'm going to go back to the luminance filter. We should be still more or less in focus. Let me take an exposure. We're going to go for plate solving. We're going to make sure that plate solving works. You can see that my stars are in focus. They should be detectable by Nina and by the plate solving algorithm. So to make sure that plate solving works, I'm just going to slew to a manual focus target. And I'm going to click on slew to target. That should move the mount, assuming you've already unparked your mount. So make sure that under equipment mount there, you've clicked on unparked mount there before doing the slew. For some mounts like on step, you even want to turn on the tracking before you can slew, but otherwise, it should be working without any issues. And now we've slewed to target. So let me take an image to see roughly where we are in the sky. And you can see that I don't see a super bright star. Maybe it's this, I don't know, but we're not on target. We're not on target, so what do we do? Well, when you were dealing with the autofocus, you were likely not on target either if you had to slew to another part of the sky as I suggested, which is fine, as long as you could see a star field. So let's go to the plate solving tab. And before that, let's double check our plate solving settings. We're using ASTAP. The ASTAP directory is set up. So in theory, it should all work. So let's go to plate solving. And here we have multiple settings. We have the sync setting and the reslew to target setting. By the way, if you don't see this tab, you need to go to this little icon there, click it, and it should appear. Sync basically means that Nina will take an exposure where it's located. It will run the plate solving, and once the plate solving has identified exactly where we are pointing, sync means we're going to tell the mount like, hey, this is actually where you're pointing, and the mount will take that and say, okay, I will update my pointing model and I know now exactly where I am pointing. This is what sync says here. So we want to turn that on because we want to tell the mount what's going on. And reslew to target, as its name would imply, is that based now on what we've seen, we can slew the mount to the correct location. And the way that it works is actually the mount does most of the work, most of the time actually. Some mounts are not so smart. But the mount will sync, so it updates inside itself where it thinks it's pointed, and then we just issue with reslew to target, we issue again a go-to command to the mount. And the mount, now that it knows where it's pointed, by getting that second go-to command to the same coordinates, it knows to move closer to those coordinates, and then we repeat until we are within a certain error amount in arc minutes. The default is 1 arc minute, and it works for most equipment. And even if your mount doesn't support the sync command, which some don't, Nina is super well built. The creator of Nina actually added that later on. Instead of relying on the mount go-to, Nina can actually compute the amount for each axis to move by to actually center the target based on the plate solving result. Some amazing stuff, like incredible stuff in Nina. Anyway, the next one is your exposure time. So I'm going to set the same as autofocus for now, 4 seconds. And you do have under your Platesolving here and exposure time. So I'm also going to set it to 4 seconds in those settings as well. And you can choose your filter, the binning. I keep everything the same, and once you're ready, you click play, and we'll see what happens. So we're going to take a 4-second exposure. It's going to be looking exactly like that, and immediately, like you didn't even see it happen, ASTAP ran like in a fraction of a second. So yeah, and we saw that we were 42 arc minutes away, so a bit more than half a degree away from the star. Now we are taking a second exposure after go to again, and bam! There we see the star is very close to center, and actually it's 24 arc seconds away from center. So we are within the error of 1 arc minute. And so Platesolving is working perfectly for us. And if it doesn't work, you really want to go, like the only thing I can think of is that the star detection didn't work. So maybe increase the exposure time. And another thing could be go back to your options, equipment, and make sure you have your focal length and pixel size and yeah, focal length and pixel size correct, because otherwise, yeah, Platesolving can have issues. Okay, so here we are. We've done Platesolving. Platesolving, it's usually a very easy check. We just check that Platesolving works, and then we're done with it, and we're fine. Okay, now we have both autofocus, Platesolving working. What is the next step that's usually causing us trouble? The Meridian Flip. And the Meridian Flip depends on several things. It depends on your mount settings, and it depends on Nina settings, and both need to be compatible with one another. Let me show you my mount settings briefly. So I'm going to disconnect the mount and click on the setting gear, and you can see I get the ASCOM driver. And what's important for me is that I have limits. For me, it's Meridian West. I'm basically telling the mount with this 5 degrees that the mount is free to move 5 degrees west past the meridian when it's imaging, because the sidereal rate is what, 0.25 degrees per minute, something like that. 5 degrees is actually 20 minutes past the meridian, right? So I'm telling the mount, please go ahead, you can keep slewing for 20 minutes past the meridian. Now there's also a problem with on-step mounts, is that these limits are actually a meridian window, and you need to be absolutely sure that in your hand controller for on-step mounts, you have set the preferred side of peer to east. And then that will work without issues. If you're using the AM5N, you don't have this problem at all. Just set your meridian limit, you know, how many degrees or minutes you can go past the meridian. And if you're using also Green Swamp server, that's fine. EQ mod as well. Just set your limits properly to tell your mounts that you can slew a little bit past the meridian if you want to be able to image through the meridian. So that's kind of like the settings. And then I can go and look at my options. And under imaging, I have these settings that we already looked at. And if I have pause before meridian to 0, it means we will not pause. We will keep imaging through the meridian, and then between 5 and 10 minutes after the meridian will affect the flip. And you saw that my mount allows me to track past the meridian up to 20 minutes. So we're fine with these settings. Note that Nina and the mount might have a slight difference in their internal clock. So they might disagree as to exactly when a target has crossed the meridian. That can cause issues. So make sure to have a margin of at least like 3-4 minutes to account for the difference in the internal clocks of the mount and of Nina, which uses the imaging PC clock. That's very important to keep in mind. And that lets me image through the meridian. If you have a Celestron mount, just like on-step, they kind of try to be too smart for their own good. If you tell the mount to point at a target that is close to the meridian but hasn't crossed it, the mount will do the meridian flip immediately. So it means that even though the target has not crossed the meridian, the mount is like, oh hey, let's make sure we don't need to do a meridian flip during the session. I'm just going to go to it from the opposite side of the meridian so that now we're good for the rest of the night. Look at how smart I am. But Nina doesn't know that. So Nina will still ask the mount to do a meridian flip, and it's not going to work. And so Nina will say, oh, I give up, and we'll stop imaging. So to avoid that, you want to get the information from the mount about which side of peer it's using. And so we have this use telescope side of peer. It's default to on. Leave it on unless you see you have some issues, because some mounts have bugs and report the wrong side of peer. So yeah, it's a whole thing. I'm also the guy who added this setting in Nina. Sorry, I realize I've built a lot in Nina. And another setting that you want, and you absolutely want to keep it on, is recenter after flip. It just means that after the meridian flip, we'll recenter the target as you would expect. Okay, so another thing is that if you have trouble with that, let's say you've set it up like that, and the meridian flip does not work for you, then it is safest to pause a few minutes from meridian, 5 minutes, 10 minutes. Maybe when you do your test, you can start with 10 minutes just to be safe. Pause 10 minutes before the meridian, and then keep the other settings the same. You could even say, like, between 10 and 15 minutes past the meridian, do the flip. What this says is that 10 minutes before the meridian, it will stop the tracking of the telescope and stop the imaging. And then 10 minutes after the meridian, it will tell the mount to go to the target. And that gives us a very wide margin, even if like the mount and Nina disagree on exactly when the meridian was crossed by the target. With that, we're really sure to get rid of that issue, and GoTo should work and the meridian flip should work. You're just losing 20 minutes of the best imaging time that you could have. That's why I like to image through the meridian by setting pause before meridian to 0 and between 5 and 10 minutes. And because the pausing before meridian and then doing the flip later works for pretty much every mount, that's what the ASIAir does by default. And that's a safe way, but you lose the best imaging time, which is a bit of a shame. So I like to track past the meridian, and that's what we're doing here. Okay, so we set our meridian flip settings. How do we test those? Well, we can kind of do a little hack there. What I'll do is I'll go to my mount, I make sure that it's not parked, and I'll go to the flat wizard that we've used previously, and I'm going to tell it to slew to zenith, but from the west side, so before meridian crossing. So I'm going to click on slew to zenith, and my telescope will slew to point to the zenith, but in a way that if it were tracking, it would cross the meridian immediately. The slew is done. I'm actually checking on my live camera of my balcony just to see what's going on with my telescope. I'm not going completely blind into it. And now that I'm done, I can go to the equipment tab. I can go to mount here. And what I'll do is I will slew a little bit to the east, like something like this, slightly. That way we're going to cross the meridian if we're tracking after a few minutes. So if I go to my imaging tab there, you can see that the tracking is stopped. So if I go back to, and if you don't have this tab, you just want to click on the telescope icon there, you'll see this. I'll go back to my mount. I will select sidereal here for the tracking speed. Click on set tracking rate. Go back to my imaging tab. Look at this, and you can see that the meridian will be in 14 minutes. Perfect. So if I want to be even tighter, I could like now slew a little bit to the west until we have less time. But like 13 minutes is fine. I want to test that out. So now I'm done with that, I can go to my sequencer. And what I'll do is I will go to my templates. I will add my default sequence there. But I need to make sure that we do not slew and center to any target. I want to stay where I am, so slew and center is gone. I don't want to do any autofocus, we're already focused. I don't want to do any guiding, this is just for a meridian flip, so I delete all of that. I don't want to wait for time, wait for horizon, none of that stuff. I don't want to autofocus after filter change. I don't want to center after drift, but I want to make sure I still have the Meridian Flip trigger enabled. And I don't want to dither after any exposure, so that's gone. And my loop conditions, I want to just loop until dawn because it's just for a test. So you can see I'm going to instructions, searching for loop. I'm going to put loop until time. The time will be astronomical dawn. I'm going to remove the altitude requirement. And then you can see it's going to take SHO exposures of 300 seconds long each. That's fine with me. Maybe I'll just go for L. I'm not going to bother with anything. And 60 seconds luminance exposures where we don't need to do one like 5 minute exposures. So now that we have a sequence there, I'm going to start it. And now it's switching to the luminance filter, and it should start. Yeah, it's starting to take exposures. I'm going to go back to my imaging tab. It's taking exposures, and now all I need to do is wait like 11 minutes plus in my options between 5 and 10 minutes, so roughly like 15, 16, 17 minutes. And then I should see a Meridian Flip, and I can see whether the Meridian Flip works properly. That's how I would test for the Meridian Flip. And actually, you'll notice that this does not depend on plate solving, autofocus, or even being able to see the stars at all. So if you keep the dust cap on, you can actually test that during the day. The center after flip will obviously not work during the day, but it will tell you whether the initiation of the Meridian Flip and the telescope actually moving to the opposite side of the meridian, whether it works. So that can be done during the day, so you don't need to waste imaging time. This technique is super cool to check. And of course, if it's during the day or even if it's at night, it's actually a great idea during the Meridian Flip when you first, testing it out, to be right next to the telescope so you can stop it. I have it on my smartphone. I'm looking at what's happening, and if something goes wrong, I will run to stop my telescope. I really should be next to it, but it's a bit exhausting to move up and down the stairs in my condition. So yeah, this hopefully will work. So what I'll do is I'll wait those additional 15 minutes or so, and then we'll look at the flip together, and hopefully it's going to work well. Okay, now we're about to cross the meridian. We're past the meridian, but we're not doing the flip yet because of our settings, right? Minutes after meridian, 5 minutes, and up to 10 minutes past the meridian. This is because it tells me now whether it should stop imaging before that 5 minutes, or if the frame will complete in between the 5 and 10 minutes, so it can keep taking one more frame and then do the flip. It's a whole little thing there. But because we're taking 60-second exposures, I expect that between 5 and 6 minutes after meridian, the flip will actually be done by Nina. So we just need to wait another, 4 minutes, 20 seconds, roughly between 4 minutes 20 and 5 minutes 20 seconds to get to the flip. So I'll see you when we're there. Okay, we're almost 5 minutes past the meridian. In 20 seconds, we'll be 5 minutes past the meridian. We're in the middle of an exposure that ends in a bit more than 30 seconds. So I actually expect that at the end of this exposure, the Meridian Flip will occur. And that's basically our test of the Meridian Flip to make sure, that it works. So we'll see whether I'm right first, whether it really ends like it does the flip at the end of this exposure, and whether the flip will actually correctly trigger and work. And as a reminder, in the sequence, we do have the Meridian Flip in there. Okay, and I'm right. And there we go, we are flipping the scope. And actually, I can see it on my camera. The scope is actually flipping exactly as expected. So the flipping during the Meridian Flip is a simple go-to command, really. It really relies on the telescope knowing that the target has crossed the meridian, and that's why, for on-step mounts, the preferred side of peer is actually important, that we set it to east, and it's also important to have some margin in the case that the mount doesn't think that the meridian has been crossed yet. There's another thing, if you're using EQ mode, you really want to flip maybe 10 minutes after the meridian, because EQ mode has some issues with sensing the mount when you do the recenter after the flip. So there's a lot of stuff. So now the flip is done. We're settling the mount, and it will recenter the scope. In this case, because I'm using a sequence that does not have coordinates, it actually remembered where it was pointed before the flip, and it will just recenter to that after the flip. Otherwise, it would use your target coordinates to do the recentering. Okay, we're recentering and using the Platesolving for that. And you can see that it's actually working, right? Not inside tolerance. We are re-slewing to the target. I don't know whether select new guide star and resume auto guider will actually do anything, because we don't have anything about guiding in the sequence. Oh no, it's actually trying to guide. I'll let it be. It's starting the guiding, resuming the auto guider. It's probably going to be fine, like in a moment. It's actually amazing that this is working. I don't get why it is working, but sometimes we just need to let it be. And now it's just, settling for 30 seconds, and we'll keep imaging, keep doing the sequence. Everything's working perfectly fine. The meridian flip has been successful. Everything is awesome. And that is how I would, test the meridian flip. If you're testing during the day with the dust cap off, closed, to make sure you're not exposing to the sun, just be ready to see any that the Platesolving after the flip will just not work. Okay, I'm happy to see the guiding is not working well. That's exactly as expected, because we need to recalibrate the guiding. I'm just going to stop it, and also to stop the sequence, because we don't need to test this more. The meridian flip has been successful, and you could see that I was imaging through the meridian, which is perfect, because we are taking full advantage of the best time of the night for that particular target. Okay, we were talking about auto guiding. That's where I want to go next in terms of like equipment, guider. There's some good stuff in there, some options here that I want to consider and to discuss with you, to see how we should be all setting them up, with regards also to PhD 2 as well. So let's get into it. Okay, and we're in the last part of this Nina tutorial series. And in this part, we'll be looking at guiding, but also at the various plugins that are available for Nina. Some of them are really so necessary that you absolutely have to install them. And for instance, 3-point polar alignment would be one of those, because it lets you get perfect polar alignment directly from Nina. And as you know, good polar alignment is essential for good guiding, good tracking, good go-to, good everything, right? And we've already set up everything else that's necessary. So let's look at the plugins tab. So we've already had a quick look at the very start of this tutorial series with the plugins tab. And the way that you want to add, that you can add a plugin, is simply to go to the available list of plugins, choose the plugin that you want to add. For instance, there is a Horizon Creator plugin. We've already shown how to create manually kind of your Horizon file in this tutorial earlier. And with this, you'd be able to actually use your mount to point to parts of your sky that are obstructed and create your Horizon file automatically, rather than having to do it manually. That said, because you have to use your mount, it's a bit cumbersome, in my opinion, but it still works and it can be a good alternative. So you would go there, click on install, and then you would need to restart Nina for it to appear. And there's tons of plugins in there, so I'm not going to go through all of them, especially since I don't know what half of them, or even more than half of them, even do. But I'll go through some of the main ones that I would suggest, and the very first one is the 3-point polar alignment. So to install it, you would just go to 3-point polar alignment and then click install. For me, it's already done, so I don't need to do that. You then need to, restart Nina as we showed earlier. And once it's installed, you have access to these options, which in general you can just leave as is, no problem with those whatsoever. And you can then go to the imaging tab, And in there, and we'll show it under the stars in a moment, you'll have the 3-point polar alignment plugin that's available here with a variety of settings. And the way that it will work is that it goes to an initial point that you can set. And from that initial point, it will move several times, actually 2 times, and take exposures each time before computing what your polar alignment error is and what you need to do to correct for that error. One thing that's fairly important is that you need to have your mount reasonably level for the instructions given by the 3-point polar alignment to be working most efficiently. I'd say up to like 2 degrees, 3 degrees off from horizontal, you're still perfectly fine. And you'll just have to have a couple of more rounds of adjustments. But anyway, with that plugin, let's see exactly how to use it under the stars, as well as the guiding, how to, after we've done the polar alignment, how to do proper settings of your guiding from Nina to PhD2. So let's get to it. Okay, so let's see how the 3-point polar alignment works after we've installed the plugin. So the plugin is in there. I have three-point polar alignment, and honestly, this shouldn't really be a plugin. It should be like default in Nina. And there are some other plugins like Nina remote control via smartphone apps, for instance, that all make the assumption that you'll have 3-point polar alignment installed in Nina. So yeah, this one is quite important. Anyway, we've installed it, and I just want to show you how it works in general and how a lot of plugins actually work. You go to the imaging tab, and on the top side, the more you add plugins, the more you'll get icons. And you have like the tools plugins, and then you have like more the hardware related plugins on the left. If we go to the tools, we see the very first one there is this little arc with 3 stars, which is the 3-star polar alignment. And bam, if I click on it, we get this interface coming up at the center of the screen. It might come somewhere else for you, in which case it might be on the right-hand side. You just want to drag and drop it to an area that's good for you to use. And you have other plugins there, like this scope control plugin that I have that lets me control my mount with nice and very large buttons in this particular case. So now let's look at the options that we have in there, just to briefly understand what's going on. There's the manual mode, which I won't really cover here. It's for when you have mostly a tracker that can control the right ascension kind of manually. And then you want to do the 3-point polar alignment. In this case, we have a nice go-to mount, and so you want to have this off in that case. And then you need to understand how it's going to work. Nina is going to point someplace in the sky, take an exposure, and use Platesolving to figure out where it's pointed at. And so obviously it means that Platesolving needs to be set up properly, which we've done earlier. We need to have the mount connected, we need to have the camera connected, and we need to have all of the parameters properly set up for all of this to work. And then it will move a certain number of degrees in a certain direction. For instance here, 10 degrees to a second point, and it turns via right ascension axis only, basically. So it would turn around the right ascension axis, 10 degrees, stop there, take a second exposure, figure out via Platesolving where it's pointed at, and then do it a third time with a second 10 degrees slew, take a third exposure, analyze that, and then it figures out how far you are away from polar alignment and how to fix your polar alignment to get it perfect. So that's this measure point distance. It's this 10 degrees between points, which works very well, and it means that in total, Nina will just consume like 20 degrees. There's very little risk of anything bad happening with such a low number. You then have the telescope move rate, which is in degrees per second. I would just recommend keeping it at the default of 3 degrees per second, unless your mount cannot support it, in which case you can lower that to something that the mount can support. Some older Takahashi mounts, for instance, might slew slower than that. And then you have something called the direction east. This setting, if I use it with this mount, it goes in the correct direction that I want it to go, I think. We'll see that in a moment. But if I use it on, I believe, the AM5N mount, it goes in the opposite direction. So east might not be like it's a relative east. It's, your other right or something like that. It's kind of weird. So you want to just test it out. And, if the telescope goes in the direction you want it to go, leave it on. If it goes in the direction you don't want it to go, set it off. and you'll be fine. And then you have something very interesting, which is, do you start from current position, or do you start from a certain position that you have the coordinates in altitude, so and azimuth here, not equatorial. And this guy there is basically more or less, at least for my latitude, like the celestial pole-ish, like home position kind of thing. But let's say I have visibility to the north celestial pole that I want to align to. But let's say you don't have visibility, you are on a smaller balcony, you don't see it. So you could manually point your telescope any point in the sky where you know that you can slew 10 degrees and then 10 more degrees and still be able to see stars. So kind of like an arc that you know you'll be able to see stars. Point your telescope to the first point on this arc and then select start from current position. And then Nina will just, or this 3-point polar alignment plugin, will start there and just use whatever portion of the sky you've fed it, and you don't need to have visibility onto the north or south celestial pole for this to work. If you're just using it like casually and you have visibility towards your celestial pole, you can just keep it as default. Then you can select the filter, which for me is the luminance filter, and we are indeed the luminance filters, so current is fine. The exposure time that you want to have for each of your plate solving, so you want to make sure it's something that's going to work for plate solving. And you can change the binning, the gain, offset, and some solver settings. I would recommend to keep it as is default, right? So let me turn off the main light there, just so that we see what happens when we run the process and what results we get. Okay, so here we go. I'm just going to click on the play button, and let's see exactly how this works. So you can see that as I click on the play button, we have this retrieving first measurement point. And so for now, it's just slewing to the initial coordinates that were set up here, right? If I had told it to start from current position, it would have started from current position. Now it's taking an image to solve, and you can see it has taken an image, and it's now moving to the next point, traveling towards the east for me, at least for this particular mount. This setting with east is on worked fine. And now it's taking a second image that it's going to solve to understand. And once it's done, it will start moving 10 more degrees, there it is, to the east, and take a third image. So it's waiting for the slew to be done, it's settling them out, and then it's going to take a third 4-second exposure. Okay, and here we go. It has computed my polar alignment error. So there's something to understand, and you'll see a message if that happens. If your polar alignment error is large, let's say more than 1/2 to 3/4 of a degree, so let's say 40 arc seconds. For me, it's 16. So we're arc minutes. For me, it's 16 arc minutes. So we're kind of good. And you see it keeps taking pictures just to refresh things automatically. But we're kind of good. I'll do some quick changes and then nothing more to do. We'll be polar aligned. But if you're far away from perfect polar alignment, more than 1/2 a degree, especially if you're using 3-point polar alignment away from the celestial pole because you're on a balcony and you don't have visibility onto the celestial pole, you want to run this twice. You want to run it once to get, like maybe not perfect polar alignment, just like go to it until it says the total error is like 15 arc minutes, something like that. Then you stop the process. You go to your telescope control settings. So I could use this plugin there. Go to the home position again. I mean, honestly, you don't really need to do that, but I like to do that just to make sure I'm all reinitialized and everything is fine and back to normal. And then you run it again, and you do the polar alignment from scratch a second time. And you might see, or you will actually likely see, that the measured error will be worse than those, let's say, 15 arc minutes that you had in the first run. And this is because you have errors that accumulate, especially if it starts with a large polar alignment mismatch. And also if you're away from the celestial pole, the longer you take to polar align your mount, the more those errors accumulate with time. And this is the case, by the way, for the ASIAir as well. So if you're using the ASIAir, it doesn't tell you anything about too large of an error, whereas the Nina 3-point polar alignment does tell you that. But yeah, Nina, if you're starting with a large error, do it twice in a row just to get better precision. Anyway, you can see that it tells me I should move to the right by 3, or let's say 4 arc minutes, and move it down by 16 arc minutes. So let me quickly do that. So I've moved it down a little bit. Let's see what happens. It's going to take another exposure. It keeps taking exposures automatically. And now you can see I've moved it down, and immediately my error is much, much lower, which is good. I can lower it a tiny bit more, something like that. See what happens. And now we're almost dialed in terms of the altitude of the mount. And as usual for polar alignment, by the way, you do not touch the mount controls themselves. You only touch the altitude and azimuth adjustment physical on your equatorial mount, right? So that's important. Let me try to see if I can get the azimuth error correct. And yeah, we are really close. I'm 1 arc minute away from polar alignment, so I'm good. But let me assume that I started from a large error. So I'm going to stop the process, and I'm going to, I don't need to go home, but I'm going to go home just so I, reset the situation. And as I'm home, I will rerun the 3-point polar alignment. So now let me run it. Go. So it's again doing the whole process. I'm going to cut to the point where it's actually gone through the whole process. And we can see that even because I spent so much time like yabbering about and explaining stuff, now it measures the error at 3 arc minutes. I'm perfectly fine with that. So I'm just going to stop this and go to my scope control plugin, go home, and now I'm ready to image. So now that we have good polar alignment, we can go ahead and make sure that we have the guiding stuff set up in Nina. And so let's go together and set up the guiding from Nina. Okay, so in Nina, if you go to the Equipment Guider tab, as we saw a bit earlier, you have multiple options for guiding. And the one that I'm going to show today is really PhD2, which is what we installed earlier. And I'm also going to briefly touch on Direct Guider as well. I'm actually going to start with that. Direct Guider is probably like the very first thing that I contributed to Nina. And this is basically if you don't have a guide scope or an off-axis guide camera, so you don't have any guiding equipment, you still want to dither between your frames. Dithering is moving your telescope a tiny bit in between your exposures so that you can average out any fixed pattern noise that you have on your camera, and you also can do some cool operations like drizzling after you've taken a lot of exposures of your target. That lets you get like more resolution kind of for free, especially if you use something like Blur Exterminator and then resampling down to restore the initial signal to noise ratio. That goes like in very deep. But the thing is, you should always remember that if you can dither, you should. That includes your professional obligations. If you can dither going to work, you should. No, so if you can dither your frames, you should. And if you do not have a guide scope or guide camera, you don't need one if you're using Nina to do dithering. Nina will do dithering in the blind. And that's the direct guider. You can just, select it, click on or tap on the connect icon, and then you can see that how many pixels do you want to dither by each time? What is your minimum settle time? And whether you want to dither only in the right ascension axis or not. Typically, if you have both right ascension and declination is doesn't have too much backlash, dithering, you can set dithering in RA only to off. That's really recommended. And the way that all of this works is that it will use the parameters of your mount and of your telescope, especially the focal length of your telescope and the pixel size of your camera. So you need to have those set up properly to estimate how long of a guide pulse Nina needs to send to your mount to move 5 pixels in this case, or whatever number of pixels, let's say 20 pixels in between frames. And it will do it in a way that is smart, in that it tries to dither in the blind, but in a way that makes sure that your target over multiple dithers stays centered. So initially when I built it, I had some really not silly, let's say silly algorithms that would basically prioritize dithering into the the opposite quadrant or even half circle from the previous dither. That way you were always sure to kind of like move around, but keep the target centered. And I've looked at the code recently, and it's been reworked into something much, much better. So yeah, it works really, really well. So if you don't have a guider, you can use this direct guider to dither. So it's really direct dithering, effectively. It doesn't do any guiding, it just does the dithering, and it's amazing. But otherwise, you would have PHD2, and if you select PHD2 in there and you click on the gear icon, you have tons of options. And the good thing is that most of the options, you're going to have access to it after you connect to PHD2. The important one, and you can leave it on like that by default unless you've done some customization when you installed PHD2. It is the PHD2 path, as well as the host name and port. And you can keep everything here default, except if you did some custom stuff. Just make sure that phd2.exec is indeed at this location. And if you click on connect here, because it knows where phd2.exec is located, it's able to launch phd2 based on this exec and tell phd2 just launch with your default profile. And phd2, you can see it has connected the camera, and it seems to have connected the mount as well. So like phd2 is like, I'm ready to go, right? So that's one of the cool things here with this integration. Now this video is not about PHD2, so I'm not going to go into the details of PHD2. I have a separate video about all of the guiding primer, the ultimate guide to guiding, something like that. I'll put the link up above, and down in the description, it really goes into all of the basics of auto guiding from setting up PHD2 to really figuring out errors or issues that you have with your guiding. And there are some parameters here. We went over them a little bit already. So in those settings, we have things like dither pixels, which is here 20 pixels. And what this means, we can look on the left-hand side exactly what that means, because we have the camera pixel scale, and it's computed for my particular setup based on the equipment information that we have set up in Nina with the focal length and the pixel size of 30.24 pixels. And that's perfectly fine for me. I like to have a number of pixels that is non-whole on my dither pixels for the main camera, so that's perfectly fine. And we also have, for information, the guider pixel scale here. So we can see that my main camera has 1 arc seconds per pixel, roughly, and my guide camera has 1.59 arc seconds per pixel, because it's an off-axis guider, so it has the same focal length as my main telescope, but it has larger pixels, which means that this dither pixels of 20 pixels on the guider will mean 30.24 pixels in terms of the dither distance that we have. And yeah, again, dither or die, so always have some nice dither going on. And if you can avoid it, dither, do not dither in RA only, dither in both directions as much as possible. And then you have the settle pixel tolerance, and the settle pixel tolerance is basically after PHD2 has done a dither, it basically restores the guiding, kind of, and when the guiding is nice and stable to within this tolerance, then PHD2 will say to Nina, yeah, we're good, I'm guiding fine, and Nina will go to the next exposure. In the meantime, Nina will wait, but Nina will wait a minimum of 10 seconds, a maximum of 40 seconds. So that's what this means, right? So right now we're saying like the settle pixel tolerance is going to be 1 pixel, which means effectively 1.59 arc seconds, which is perfectly fine. We're going to wait for that to be at least 10 seconds so that we know this is not a fluke, right? We're just like constantly within that 1.6 arc seconds. And if after 40 seconds, PHD2 has still not told us like it's stable and good, we're going to image anyway, right? We're going to stop waiting for PHD2. And so those parameters are very much dependent on your equipment and how well it works for you, and you might need to fine-tune them for yourself. Guiding start retry, if it has trouble starting guiding, you can ask it to retry, so that you could turn that on if you ever have issues. Otherwise, you can leave it at off. And then you have guiding start timeout, how long Nina will wait for PhD to start guiding. After a Meridian Flip, for instance, Nina will send a start guiding command to PhD2. At the start of a sequence or after it has slewed to a new target, it will send a start command, depending on how you set up your sequence, and how long it will wait until PhD2 reports back to Nina, hey, I've started successfully, right? And then after 300 seconds, Nina will okay, never mind, even though I didn't hear from PhD2, I'll just start imaging anyway. Or if you have the retry, it will try again. Then there's the ROI percentage to find guide star, whether you want to limit, where PhD2 will look for a guide star. I recommend just leaving it at 100%. You don't want, especially if you're using an off-axis guider and you have a limited field of view on your guide chip, you just want to keep it at 100%. And then here you have the PhD2 profile that you want Nina to launch automatically. And I'm using my Newtonian telescope, so I want to use my nude profile, and this corresponds to equipment profile. So if I stop the exposures, I go to my profiles there. I'm gonna disconnect all just to show you. We have SQF55 and Newt profiles with different drivers, different hardware, different focal lengths set up. Everything is set up differently, right? So we tell Nina which profile to use, and in my case, it is the Newtonian here. And that's all of the setup in there. And then of course, there are the guide commands in the sequencer, as well the dithering commands in the sequencer. So if I go to my Sky Atlas, I select whatever, M31, it's not really visible these days, but I don't care. I'm going to add a target to the sequencer as a monochrome sequence. You can see that part of my sequence is like here, start guiding. And under start guiding, you even have force calibration or not. If you're familiar with PhD2, you know that if it's on a new equipment setup, PhD2 will, at the very first thing, do a guiding calibration. It will basically move the mount around like by small increments in all directions and then figure out how much that actually moves the stars on its own guide chip to see like, hey, if I tell it to move like 1 second in the north direction, how many pixels can I expect my star to move by on my guide chip and in what direction? And it does the same for south, west, and east. And then it figures out exactly how it needs to work. It's pure magic. And you could force the calibration to tell PhD2, like by default, PhD2, if you're using ASCOM to connect to the telescope from PhD2, it will remember that calibration. It doesn't care where it's pointed in the sky, it remembers that calibration. And then it will reuse it. But if you don't want PhD to reuse that calibration, you can just say like force calibration to on, and it will do that. And so that's this start guiding stuff. And then we have the trigger dither after 3 exposures. Every 3 exposures, in this particular case, will do 1 dither of PhD2, or if you have set up the direct guider, so what we showed earlier, it will do the dither in the blind to do this, to achieve this particular command. You have some other triggers, by the way, that can help you kind of rescue guiding if there are issues. I could say like, hey, have a trigger that restores guiding if for whatever reason it was interrupted. Like if Nina detects interrupted guiding, just restore the guiding, which can, because it starts the guiding again, you have this 300-second timeout that could eat into your imaging time. So it's always something to think about, like what exactly do you want to do? And then, of course, you have a stop guiding command that you typically never need to have in your sequence, but it's available. And all of those like set guider shift rate and the trigger as well as stop guider track shift. I do believe that this is part of a plugin that I have installed, which is called Orbitals, that lets you basically find planetary type of targets like comets, asteroids, the planets in the solar system, that kind of stuff. So with that, you may want to guide at a non-sidereal speed. So that's where these commands come from, but they're not useful to us. So I'm just going to skip them. So in the end, how did this all look like. I can simply, go to my imaging tab. I'm gonna go to my manual focus targets. Yeah, Vega, that's good. I'm gonna slew to Vega. And it tells me there's some weird stuff there, so that it should redo another calibration rather than reuse something that already exists. So we're probably going to see some really weird results, but that's not really the point. We can see the guide graph here in PhD2, and you've probably noticed that underneath here in Nina, we have the same guide graph appearing in Nina. So you can monitor what's going on here from the Nina interface, and you can see on this guide chart exactly what's going on, what is your total guiding figure, what is the figure in declination, in right ascension, and you have all of the corrections as well. So you have the main information here available directly in the Nina interface. And similarly, if you go under Equipment, Guider, you have access to the same graph. You can change the unit to be arc seconds, and then you see exactly what's going on. So that's the usual stuff. It works great, and that's the gist of it in Nina. Again, if you want more details about how to set up guiding, how to do guiding calibration in PhD2, etc., I have another video on the topic. The link is down in the description if you're interested. So that's for the guiding. Let's look. Now that we've looked at the 3-point polar alignment to get good polar alignment, which is critical for good guiding, and we've looked at the guiding settings and how it all works, including in sequence, let's have a look at some other plugins. And one of the plugins that I want to show you is something that I have installed, which is called the Filter Offset Calculator. So there's nothing to see here, move along. And that's a very simple plugin that can be doing something really, really nice. So let me go to the Imaging tab, and under the Imaging tab, you will have a new icon, this guy here, Filter Offset Calculator. And if you click it, this tab will appear here somewhere in your interface. And what this does is that it will go through each of the filters that you have selected there, and it will do autofocus runs. For example, it will do here 3 autofocus runs in luminance, 3 autofocus run in red, green, blue, sulfur, H-alpha, and oxygen 3, all of my filters. And I need to make sure it has the dark filter disabled. And then it will set that up under Options, Autofocus, and the focus offset that we have here. So it will set that up automatically for you so that you can set a default autofocus filter. For instance, the luminance one could be your default autofocus filter if you have like the use filter offsets as on, and set this as the default autofocus filter. And you can also avoid refocusing when you change your filter on the filter wheel. It is super powerful, and this plugin lets you do that automatically. And just to show you how it looks like, we're going to set to the minimum number of iteration, which is 2, and I'll just let it run on luminance and red, just those 2. I'm going to click play and show you what happens. So you can see immediately autofocus is getting run. And let's wait a little bit for this particular autofocus run to be complete. And there you can see it has done 1 autofocus on luminance. It took 2 minutes. I'll let it do a second run on luminance, and then what's going to happen is that it's going to switch to the red filter and do exactly the same thing. Do 2 autofocus runs, and for each it will compute the average best focus point, and that will be put into the filter offsets. So let this process finish on its own, and I'll show you what happens when it has finished running. And so at the end, this is what it looks like. So actually I was kind of wrong in the order of things. It did 1 autofocus for luminance, then 1 for red, then back to luminance, and then back to red. This is to make sure it averages out, every other condition. It loops through the filters rather than one after the other, just to make sure that temperature changes, which affect the tube length, for instance, by some microns, which can affect the focus points, are kind of averaged out by going through each filter one after another, and then a second iteration, and then maybe a third iteration with the default settings. And then we get something like this. These are our current offsets set to 0, and the new ones will be 50-37 and 50-40. This is the QHY Minicam 8. I've already shown that for this camera, the filters are pretty much perfectly parfocal. So the offsets don't really, do anything for us. But you can see, I can say like, yeah, let's accept that. Let's use relative offsets and let's set luminance as my autofocus filter. Click on accept. And now if I go to my options, autofocus, you can see that luminance is my autofocus filter. We have use filter offsets, and you can see the filter offset has been set to just 3 here because we had only a 3-step difference between luminance and red. And obviously I should have taken for all of the filters, but I wanted for time purposes to quickly show you how it would look like. And it warned me like less than 2 filters selected for offset calculation. It's absolutely right. I should have all of the filters selected except dark, because the dark filter is obviously unrelated to any of that. And that is the filter offset calculation plugin. And you can see it's very useful if you have a monochrome camera. Some other plugins of interest would be things like Connector. This is just a plugin that allows you to put connection and disconnection instructions in your advanced sequencer. So if I go to my advanced sequencer, at any point I could say like, okay, I want to disconnect a piece of equipment, something like during the, after I've done my imaging. Let's say I want to make sure that I disconnect my camera after it has warmed up, for instance. I could disconnect all of the equipment. All of these connector stuff are provided by that particular plugin. I think it's very nice to have. You could also make sure that your equipment is connected at the very start by having this connect all equipment instruction at the very start of your sequence. So that's some really neat tricks to have and to use as this connector plugin. Okay, so that's a very straightforward one. Then we have plugins that let you have better or potentially better autofocus. And this is called Hocus Focus. And it kind of replaces the Nina engine if you wish to do so. And in addition to that, Hocus Focus lets you have an aberration inspector of your images, so it can measure the tilt and curvature of your field of view fairly precisely. And so if you have a tilt adjuster, you can use Hocus Focus to really adjust the tilt very precisely on your tilt adjuster. And if you want to use it, like if you have trouble with the vanilla autofocus and you want to use Hocus Focus instead, you would need to install it, and then under the options and then imaging, you'd want to go to the star detector, star annotator, and autofocus and switch those to Hocus Focus to use the plugin instead of the vanilla Nina stuff. So if despite this tutorial you had trouble like setting up the autofocus for Nina, like the stars didn't get detected or you don't get those nice V curves, something is going wrong, one thing you could try is go to the plugins, install the Hocus Focus, and then replace the default Nina autofocus with the Hocus Focus autofocus. That's a mouthful. And there's tons of settings in there. I'm not really going to go into them because I haven't really used Hocus Focus enough to really know how to use it well. I just know I've used it with the default settings. It worked great for me, but then so does the vanilla Nina autofocus for me. So I don't know really what more instructions to give based on my own experience, as I've not experienced the issues that you may be having. So, but that's still another one to have in your book, right? To have available if you have any trouble with autofocusing or you have a tilt adjuster and you want to really have this aberration inspector to see how well or what screw you should be using to adjust the tilt. Another plugin that I find really, really nice is this ground station plugin. And this ground station plugin lets you get instructions in the sequencer to warn you if you have any issues with the sequence. So let's say you're not in bed yet and your sequence is running without any issues. You're watching a movie, spending time with your significant other. Oh my word, what is going on? And something goes wrong with the sequence, then this ground station, plugin can send you an alert directly to your phone via a variety of techniques. There's pushover, telegram, email, if this then that, IFTTT, right, and other protocols in there. The ones that I was using personally was pushover. Pushover is like you have to do a one-time $5 payment and then you can use it as much as you like. Once you've signed up for it, you can install an app on your phone, whether it's iOS or Android. And if you log in, you'll get an API key. And you can put that API key and user key, actually 2 things, in there. And then Pushover will be able to send you some alerts directly on your phone with notification, etc. So you can keep track of anything that's going on. And in the sequencer, if I search for pushover, at any point in the sequence, I could say like, hey, send a message to pushover, like starting imaging on M31, you know, that kind of stuff. Like that's like for you to, when you reach a specific point in the sequence, bam, you say like, let's send a message to pushover, just so that you can be kept abreast of what's happening without having to actually check on Nina. Or you have a trigger as well, which sends an event to pushover whenever an instruction fails in your loop. So let me add a real sequence so we can see exactly what's going to happen. So let's say I add a sequence to for M31, and then I could add, let's say, in here, failures to pushover as one of the triggers. And then any of the instructions below has an issues, it will send an error to pushover with whatever priority you want and whatever sound you want. So it's a pretty powerful thing. And there's, you know, pushover is just one example of an integration. You have other integrations as well to receive notifications if something is going wrong. And there's other plugins that let you do that. There's this Discord notification thing where you can send a webhook, basically an alarm via URL, to a Discord server, and then you get a notification from your Discord app on your phone. It does require you to be a bit more technically aware than something like pushover. But you see, that's like for being aware of what's going on with your sequence without having to monitor it. And it's really nice. It's also super stressful. And I can tell you that my wife absolutely despises this plugin, Ground Station in particular, which is why these days I'm not using it. I'm just letting my sequences fail silently. It's better for, you know, life in general. So there you go. Otherwise, there's some simple ones as well, like Arbiculum, which works in a sequence. And that's when you have multiple targets. So let me add multiple targets. Let's say I want to add like M42. I know it's like, in this season it makes 0 sense, but I don't care. I'm just going to add M42 as a target. And then while I'm on the M31 instructions, instead of something like loop until the altitude of my current target is below some certain altitude, I can tell Nina to look ahead. And that's using Arbiculum. So you'll have a new section called Arbiculum under your instructions. And in there, there's like, you know, loop while the next target is below a certain altitude. So I could say like, okay, instead of looping until you're below 30 degrees, whenever my next target reaches 45 degrees, then we go to it. And so your loop on M31 depends on the altitude of your next target, rather than the altitude of M31. It's a pretty cool stuff, and it really lets Nina, the sequencer, look ahead to what's coming next. So I really recommend having that as a plugin if you want to really, you know, fine-tune your advanced sequencer and you're doing multiple targets in a single night. Some other simple ones would be things like scope control. We looked at it a bit earlier, I think, under the stars. And scope control lets you add this tab here, scope control, where you can, you know, say to the mount, like park the mount, go to home, start tracking, move in that direction, change the rate of movement, that kind of stuff. Simple stuff. And when it's in the imaging tab, by the way, whether it's 3-point alignment or scope control, we'll see the same under the stars, but you can use the icons there at the top to enable and disable that screen. And you can hover over any one of those icons to get a description of exactly what this icon controls. So that's some other simple plugin that can be useful to have. Another one that I really like is Remote Copy. This one lets you, in a sequence, add some instructions to say like, hey, copy the files from my picture folder in Nina to another folder, which can be on the same computer, or more interestingly, which can be on a network access storage. So that regularly Nina will copy your image files, the one that haven't been copied yet, to that other folder on network access storage or directly on your processing computer, so that when you wake up in the morning, all of your files are on your processing computer. You don't need to transfer files from like your Nina computer to your processing computer or to your NAS, whatever. It's done automatically for you. And you can do that with remote copy. So if I'm in the sequencer, I could say like, maybe I want everything to work normally during the whole session. And then because the sun like rises at like what, 4:30 a.m. in Japan these days, meaning it starts to get bright at 3:30, even 3 a.m., then I have ample time for Nina to automatically copy everything. So as part of my, end sequence, so let's say I have my standard end template, like where is it? My awesome end, there it is. My awesome end, I could add an instruction in there that says, probably not even in parallel, I'll have it at the very end before disconnect all of the equipment. I could have, let's search for robocopy start. And I'll have it, let's say, even after I disconnect all of the equipment, from the folder where I save all of my Nina stuff to another folder. And in particular, if you're in Explorer, and you want to copy those files to a network drive or to another folder that's on a share on your processing PC, you would need to make sure that the share is completely done on the processing PC. I have an old video about how to do that. If I remember, I'll put the link up above and down in the description. But basically, once you have the share properly working, you can, on your imaging PC with Nina, you can add a network drive, a mapped drive, sorry, and then you can put the address to your folder in there. Click finish. It should hopefully work. There it is, and now I have my NAS, my network access storage available directly from the Nina PC. So I could say robocopy start and copy the files in the Nina pictures folder, and then the destination will be my NAS drive there under, let's say, to process, and then I can have my a secondary folder, whatever, I don't care. Select folder, and now it will copy any file that is in there that isn't already in there, then gets copied. Super powerful stuff. So that's another really cool plugin to have. And by the way, like if you are watching and you have some recommended plugins, please let us know down in the comments, because there's tons of cool stuff around there and so many plugins, and I don't know many of them. So everyone, check the comments, see if other people have other ideas. While you're there, leave a comment, leave a like on the video. It really helps the channel out. If you're new and you like this kind of tutorial or equipment reviews, etc., you could consider subscribing. It really helps the channel out. And if you want to support even more, and you're planning on buying anything from Agena, High Point Scientific, or even Amazon, if you do so after clicking one of the links that I have down in the description, it helps me out at no cost to you. If you want to sponsor the channel directly, you can become a channel member. It's the join button next to the subscribe button, or a Patreon supporter, and that is a link down in the description. Some of my Patreon ranks have access to my videos early and without ads, and I have an experiment going on with a Discord server for my Patreon members. So if that sounds interesting and you want to support the channel directly, there's that too. Anyway, let's go back to the rest of the tutorial here. There's some other cool stuff like orbitals that lets you effectively find comets, asteroids, planets, etc. And also it will automatically update the orbital parameters of all of those objects for you. So if I go in the imaging tab and I have this little icon there for orbitals, that opens up a tab here. And you can see that you have comets, numbered asteroids, unnumbered asteroids, James Webb telescope if you want to image the James Webb telescope to see where it is in the sky. If you click on update, it will update the coordinates or the orbital parameters of that thing. It will also, I think, find comets from this MPC or JPL database, and there you can see it has 1,209 comets available, and so you can keep track of solar system comets, asteroid kind of objects, and have them be able to slew to them easily. And then under the very top of your instructions here, under instruction set, you have like orbital object sequence that can drag and drop. So I already have one there, but I could say like drag and drop, and then you can select your comet, asteroid, etc. Just put in the name, it will search for it, add it, and then create your sequence kind of as usual. You can do the same with a solar system object body sequence. Say like, yeah, I want to image Saturn, whatever. And you have that, and you can slew to Saturn, have the proper rate for that, etc. And you have similar stuff for the James Webb Space Telescope if you want to image James Webb, which is very low in the horizon for me, obviously, but it's available there as well. All of those things available together with some more in-depth telescope control, like setting the telescope tracking rate for the particular object that you are imaging. So some really powerful stuff if you're into the non-deep space imaging, let's say the more, well, orbital related stuff as a plugin. Now I'll go to some very interesting plugins as well, which let you control Nina directly from a smartphone app, with actually two smartphone apps that are available. One is more ASIAir looking, the other is more like Nina looking, I would say. And I'll go to that in a moment, but before that, some other little cool stuff. If you have an astromechanics adapter, you can control aperture of Canon lenses via your adapter using this little plugin there. You have an autofocus report analysis to really tell you what's going on with your autofocus. You have an exposure calculator that gets you your optimal exposure time based on your sky conditions. Optimal are what I like to call minimum exposure time based on sky conditions. You have the lens autofocus plugin that if you're using a Canon DSLR with a Canon lens, you can control the autofocus or the focus motor of that lens through the Canon DSLR body, in addition to taking pictures from that. I haven't tested it, but it looks really useful. Then you have some stuff for people who like to image when the moon is up, like the moon angle plugin. And this one lets you basically in your sequence start and stop a sequence or a target depending on how far away it is in terms of degrees from the moon. Another one of those plugins is Smart Filters that lets you kind of figure out how much or how you need to set up your filter exposures to reach some certain specific like exposure targets for each of your filters. Some really cool stuff in there. Then this one called synchronization is if you have multiple telescopes on the same mount and you are using two instances of Nina to control them. If you install this plugin on both, you can have synchronized dithering between the two, meaning that if one of the telescopes is still imaging and the other telescope wants to dither, the other telescope will wait for the first one to finish its exposure before doing dithering, and while it's dithering, the first telescope will wait until doing the next exposure. So it's a synchronized dithering mechanism between the two telescopes mounted on the same mount. You have the Target Scheduler, which is an insanely complex plugin that I still haven't managed to wrap my head around, but lets you basically automate your whole imaging. No more need to create sequences. This plugin, you just tell this plugin what you want to image and your some specific criteria that you want to fulfill, and then this plugin will just create the sequence for you and automatically do everything, as far as I understand. But it has a lot of documentation. I haven't managed to get into it yet. I kind of like doing my sequences manually still. Maybe I'm not lazy enough. Maybe I'm just a control freak. But that's a good one to look into. Okay, and then we get into the cool stuff that lets you control everything from really nice looking smartphone apps like the Advanced API plugin and Touch and Stars plugin. So I'm going to go to my installed plugins list. You have them here, Advanced API and Touch and Stars. So you really want to have, for these to work, Advanced API, and there's some security issues with that, but you need to make sure that you have this checkbox like use access control, allow origin header set to on. And you also want to make sure that you have the 3-point polar alignment installed to make sure that everything works. Those two are sufficient to use a free app on Android and iOS called Cygnus Astro. That's already really, really nice. And if you want an app that has a different interface and gives you access to a bit more features, it's Touch and Stars that requires you to install the Touch and Stars plugin. By the way, when you install or update the Touch and Stars plugin, unlike other plugins, it can take like a couple of minutes to install under Nina. So just let it run, be patient, go take a cup of tea, and let it do its thing. The installation takes much longer than expected, to the point that sometimes I think like, oh, has it crashed? It's not doing anything. I'm going to stop Nina. No. Just let it be. It will install or update itself. Don't worry about it. So let's see what happens when you have Advanced API as well as 3-point polar alignment installed. So Advanced API, you want to make sure that you keep everything the same, and in particular this API port. And then you want to have a smartphone that is connected to the same network as your Nina computer. So here we're all on the same house network. My telescope is on my rooftop balcony, 2 or 3 floors above me, and I'm on my computer in my living room, and my smartphone is connected to the same network as everything else. So I have direct access to it. And I have installed the Advanced API, and it's active. Nina is installed, Nina is running, everything is good. Let's see how this would look like when using the app called Cygnus Astro. Okay, so I'm on my smartphone and I have this app which is available on the App Store. Simply enough, just search for it, Cygnus Astro. And I'm going to open up Cygnus Astro, and we get this powered by Nina Advanced API thing. And you can see this super cool interface that is very similar to the ASIAir. And I can go ahead and connect all of my pieces of equipment in there. You can see we have the mount control there, so I can, and this is because Nina is already connected to the mount. So I can actually, move it around, set the trackings to sidereal, slew to zenith to take flat frames, the usual stuff that is available in Nina, and I can disconnect and reconnect it, and you can see the mount is currently at the home position already. So we have that. Then you have the camera as well. And here you can do the same thing. Right now we are not connected to the camera, which means that Nina itself is not connected to the camera. So I can select QHY Minicam 8M, click on or tap on the connect button, and Nina in the background will connect to the camera. And once it's ready, there we go. We have access to a camera. It's currently at roughly 20 degrees or 20.1 degrees Celsius. It is not cooling, but I can tell it like, hey, cool yourself. And we should, after seeing the tab there, bam, the camera is cooling itself and the temperature is already dropping. And we have all of the information about the telescope in here as well. I'm telling it to warm itself. I don't need to cool it right now because we're not imaging just right now. But this is the way that this can work. This is really pretty cool. Then you could go for the focuser. So for me, it is FP2 ASCOM. It's a Gemini focuser. And why I need to connect that, again, it's because Nina hasn't connected to the equipment yet. I could tell Nina to just connect to everything, and this would be available without me having to do anything. And here it is. You can see that my current position is 50-41. I could tell the focuser to move to like 50-50, let's say instead of 50-41. Done, move. It's moving right now. The focuser, the whole focus assembly is moving, and now we are at 50-50. Amazing stuff. If we were during the night, I could do an autofocus and it would just show it to you directly in here. And you can see here, this is the last autofocus that I did. Actually, it's part of the autofocuses that we did together with the filter offset calculator plugin. And I think that's all pretty cool, and it's a very familiar interface if you're someone who's used to the ASIAir. And this is your main kind of ASIAir lookalike environment where you can have your telescope information, you have your guiding information. I'm going to skip that and go directly to the guiding because we want to make sure that we are connected to PhD2. So by doing that and clicking on connect, again, it just tells Nina, please connect to PhD2. So in the background, just like we've shown earlier in this video, it will just start PhD2, loop, and there we could, again, if we were under a starry sky, start the guiding, or even force it to calibrate as we start guiding with this checkbox here effectively. And then we have other devices that we can connect. For instance, I would want to connect my filter wheel. There we go, and I could change the filter to luminance, for instance. And there it is, it's moving to luminance filter, and momentarily it will tell me that it has finished moving to luminance, and there it is. We are on luminance for the filter wheel. You can also select a switch device if you have something like the RB Focus Gaius S2 computer, or something that has an ASCOM controllable USB and DC power hub. That would be from here. Unfortunately, there is no flip-flap panel yet that I can see, but you can see you also have an interface for 3-point polar alignment. So you have kind of all of the basics in here, and if I go back to the main imaging tab, I can check my focus information there and move the focuser around. So it's like 50-47, but now it has moved 20 steps upwards to, 50 steps upwards to 1597, bring it back to 50-47. It's like very similar interface to the ASIAir. I have the telescope that can move around, and I have the guide graph as well. I mean, come on, that's absolutely insane. It's amazing. It's so cool to have all of that available directly from a smartphone interface, as long as you're on the same network as the computer that runs Nina. And if the computer that runs Nina is something like the Gaius S2, it emits its own hotspot. So you just need to connect your smartphone to the Gaius S2 hotspot, and then you have this available, just like the ASIAir. It's like, basically it's the same thing as the ASIAir, just you have all the power of Nina and all of the capabilities and all of the supported equipment of Nina instead of just the ASIAir stuff. So I think that's absolutely insane and amazing. You can also drag and drop here the left-hand side panel to go and see what sequencer you have in there. So we have all of the stuff that we just added from the orbitals like JWST, etc. We have M31, and under each you can see exactly all of the steps that have been put in there, and you could start the sequence, stop it, reset it, etc. At this stage, I don't think that you're able to change any of the actual steps directly, but this is already pretty cool. And so that's the Cygnus Astro app that works if you have the advanced API installed under Nina as a plugin. And this is amazing. I absolutely love this. Okay, what about the other one, Touch and Stars, that requires you to have 3-point polar alignment, advanced API with that checkbox that we saw earlier, and the Touch and Stars plugin installed? Let's have a look. So, Touch and Stars, I'm going to open it. And here we are with Touch and Stars. And for Touch and Stars, I have a separate video where I presented this to you guys. So I'll put, again, if I remember, the link up above and down in the description. And Touch and Stars is available directly from the App Store as well. Now, Touch and Stars, in terms of initial setup, it has a setup wizard that has you basically input the either the host name or the IP address of the computer running Nina. So it's not as pretty as Cygnus Astro. Cygnus Astro just like detects your computer running Nina and gives you the interface like immediately. I don't know how it would work if you had multiple computers running Nina at the same time on the same network. I haven't tested that yet. Touch and Stars, if I go to the settings, you can see I have my RB Focus 149, which is my Gaius S2 computer, as one of the options. And then I have another one, which is the computer I'm connected to right now, which is this My Astro computer that I needed to set up initially with the proper parameters. But once it's done, you have access to all of the power of everything, just like you did effectively in the previous app, Cygnus Astro. So let's go to the first tab here, which is the connecting the equipment. You can connect everything, and again, it just instructs Nina to connect to all of the equipment. And in particular, we have the flat device that Cygnus Astro wasn't able to connect to because it doesn't have that setting in there. I can tell Nina to connect to the flat device, and we have connected to the flat device. And if you have a dome or as well, you could connect it from here. And then you could go to the camera tab here, and just like in Cygnus Astro, really, you can just take a 1-second exposure, for instance. So if you take a 1-second exposure, bam, you get the result. It's just a dark frame. And by the way, I didn't show it in Cygnus Astro, but it's exactly the same thing. If I go back to Cygnus Astro and I take an exposure, bam, we should see exactly the same thing. But because Cygnus Astro is in landscape mode, you have more field of view immediately in the image than you do with touch and stars. Now in this particular tab, again, you have tons of cool controls for your mount, for your focuser, and also for your filter, to change the filter to whatever you want based on your filter wheel. And you also have access via the settings tab here to everything about the camera, including the gain, offset, set up the temperature of the camera, the parameters of the camera, everything is in there. It reminds me, more than it does of the ASIAir, it reminds me of the StellarMate Pro and StellarMate OS, just a bit more intuitive and touch-friendly in the way that it works. But this is really nice as well to have at the tip of your fingertips. You also have the focuser tab directly, where you can start your autofocus and see the autofocus graph as it runs. You have your mount tab, and in the mount tab you can, unpark, move the mount manually, etc. You can also slew the mount to a specific target. You could search for M31. Will that work? Yeah. And then I have the M41 interesting stuff, and I could slew to it, slew and center, open in Framing Assistant. How insane is this? And then choose my framing. Dude, this is absolutely amazing. It's insane that we're able to do this these days. Determine the rotation from the camera, etc., etc. This is amazing. And then within the mount tab as well, you have the 3-point pole alignment that you can start just like you could from the Cygnus Astro app, but it's all on your smartphone. Again, you just need to connect to the same network as the computer running Nina. If it's the RV Focus Guy SS2, it has its own hotspot. Connect to a hotspot and you're golden, just like the ASIAir. I find this amazing. Then you have the flat panel where you can, the cover is currently closed. I can turn on the light on my flat panel. There it is. Change the brightness, take flat frames, because of course you have the flat wizard available now that I have the flat panel there. And you could say, like, I want to have auto brightness of my flat panel to target an exposure time of 1 second, and I want to do it for filter luminance. Start and do my flats for me directly in there. So you can see that touch and stars, it's probably not quite as pretty, I would say, as Cygnus Astro, and you need to set up your IP address and stuff like that, or our host name for a computer. But wow, does it have many features packed in there. It really lets you control almost everything about Nina. You have the guiding stuff in there as well, just as expected. I already showed the flat wizard. You have also a planetarium software right in there. So you can choose anything and slew to it. And you can search for stuff directly in there. And I can change the time so it's dark. So let's put it at like 21:05 today. And then we can see what's going on and what targets we have. And let's see, I select this target and you can see I can slew to it, slew and center, go to framing because I want to frame the target. So now it's gonna frame the target. I can open the framing assistant and oh, come on, how amazing is this? I mean, I want to use this more than I want to use the Nina interface on desktop. This is insane. This is so cool, right? So you have all of that available literally at your fingertips with this planetarium software there. I mean, I love this. And then finally, the tab I didn't go to yet is this sequencer tab. And again, you need to drag and drop this top bar there. If you're not used to it, it would look like there's not a lot of features. So remember, drag and drop, and there you can start the sequence, stop the sequence. And if you tap on the edit button, I don't think you can add stuff to the sequence yet, or at least if you can, I haven't figured out how, but it makes this turn on and off kind of button available. So you can turn on and off parts of the sequence as you require. So there's some limited ability to change the sequence that you have. Still, overall, this is pretty amazing, and I know that they are working on adding a full like sequencer edit in here. And so then when we have that, this like Nina plus Touch and Stars or Cygnus Astro plus the plugin Advanced API plus something like a Gaius S2, it becomes a complete 100% replacement for the ASIAir, except that it's a more powerful replacement that supports more hardware. Amazing stuff. And that effectively concludes my tutorial or my how-to for Nina. I think it's running something like 4 hours in total, something like that. So I have it already published in different parts, but you might be watching a video where I have put everything together into a single primer, like the ultimate guide to Nina, and I hope it's really useful to you guys. If it is, or if you have further tips and tricks, let us know down in the comments, and really comment, just shout out anything you like. It really helps the visibility of the video by interacting with it. Like the videos as well, it really helps out. And again, you can subscribe to the channel, or if you want to support the channel even more at no cost to you, and you're planning on buying anything, even if it's not Astro related, from Amazon, Agena, High Point Scientific, First Light Optics, astroshop.eu, etc., if you do so after clicking one of the links that I have down in the description, it will help me out, again, at no cost to you. And if you want to sponsor the channel directly, make all of this work possible directly, you can join the channel as a member. It's the join button next to the subscribe button, or join as a Patreon member. The link is down in the description. Again, some of my Patreon ranks have access to my videos early without ads. And I have a Discord experiment going on for my Patreon members. With that, I hope this video was useful. Let us know down again in the comments whether you have some cool plugins you'd like to highlight. But more important than all of that, as always, thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.